Hi everyone, my name is Meta Tamal. I am a developer advocate at Google, and today I want to talk to you about choreography versus orchestration in serverless microservices. Now, first of all, what do I mean by choreography versus orchestration? Let's imagine a simple e-commerce transaction. In this transaction, you receive orders through a front end, then you authorize and charge the credit card of the user in a Cloud Run service. Then you prepare and ship the item from a cloud function. And finally, you notify the user from another Cloud Run service. In this model, you have four microservices, and they're calling each other directly through REST. What are the pros and cons of this simple REST-based approach? First of all, it's better than a single monolith. You don't want to put all these services together in a single application. So it's good that they are distributed. And it's also easy to implement. Services simply call the next service in the chain. On the other hand, you already have too much coupling between all the services. Each service has to know the next service, and it needs to make the call to the next service. Similarly, each service can be a single point of failure. What if a service in the middle fails? The whole chain breaks. And if there's an error, then each service needs to handle the error, and it needs to retry, and it needs to apply some kind of timeout policy. So all those have to happen within each service. And most importantly, who ensures that the whole transaction is successful? Each service can make sure that their part is done, but there's no one watching globally. Now, what you can do is you can take a different approach, and you can do an event-driven system, also known as choreography. In this model, the front end still receives the requests from the users, but instead of calling the next service in the chain, it just creates a message and puts to a message broker. Then whoever is interested in that order request will receive that message. In this case, payment processor. It will process and emit another message. Now in this model, as you can see, services, they don't really know about each other. They're just receiving messages and emitting messages as they go along. Now in this event-driven model, things work, but imagine a more complex transaction where you have an inventory, you need to check the inventory, where you need to take decisions based on the stock, having the stock or not, where you might need to call a third-party API. How do you do that in an event-driven way? It is certainly possible, but it becomes much more complicated. So the pros and cons of choreography is that, first of all, in choreography, services are loosely coupled, which is a good thing. Services can be changed and scaled independently, which is very important. And you don't have a single point of failure. If a service doesn't work, the rest of the services, they can still receive messages and they can respond with messages as well. And events in general, they're useful if you want to extend the system. If you want to add a new service, for example, it's very easy to plug it in and just configure it to receive messages that it is interested in. On the other hand, now the system is becoming difficult to monitor because with all these events flying around, it's hard to track where something fails. If you need to apply some kind of error, retry, or timeout policy, then you need to apply those still individually. There's no central place for that. And the business flow, the way your business is defined, it's not that obvious anymore. You can't point somewhere in your system where you say, this is my business flow. Instead, it happens as a side product of your event system, but there's no single place for your business flow. And again, most importantly, who ensures that the whole transaction is actually successful? Each service can make sure that it can receive and respond with messages, but there is no one watching globally. That is still a problem. Now you can take yet another approach called orchestration. And in this approach, what you do is you still receive the request from a front end, but instead of calling the next service in the chain, or instead of emitting a message, you call an orchestrator. An orchestrator, it's an external service, and it calls the next services in the order that they are supposed to be called. Right? So in this case, for example, the orchestrator will call the payment processor, and once that's successful, it will call the shipper, And once that's successful, it will call the notifier. And since orchestrator it's a central place, it can also act on errors. So if something fails in the middle, it can report that globally. And it can also apply global error policies and retry policies and things like that. Now, the pros and cons of orchestration is that the business flow can be captured centrally in the orchestrator. And once you capture it, you can actually source control it. And this is very useful. Each step can be monitored because orchestrator knows what to call and how to call it. And if something fails, it's very easy to see. All these errors, retries, and timeouts, they can be centralized, which means you can have global policies that can apply it in a single place from the orchestrator. And you are still using simple REST. So the orchestrator still makes REST calls, so you don't have to deal with the complexity that comes with events and event parsing. And services are still independent. They can still be deployed independently and they can scale independently. It's just orchestrator calling them instead of them calling each other. On the other hand, you have a new orchestrator service that you need to learn and you need to worry about. So you need to make sure that it's actually a resilient and redundant service. Orchestrator could be a single point of failure. So you need to make sure that your orchestrator is actually up to the task. And since you rely on task in orchestrator, you lose the flexibility of eventing. And this inherently means that you have more tight coupling between your services. If you need to introduce a new service, you can't just plug it into your system. You need to actually configure it within the orchestrator as well. So which one is better, choreography or orchestration? And the answer is, it really depends on what you're trying to do. There's no hard and fast rule on one is better than the other, but I think there are certain things that you can look for and see if certain use cases are better for choreography versus orchestration. So for example, if your services are not that closely related, you are probably better off with choreography. And if your services can exist in different contexts, so for example, if your notifier service can live in your checkout process, but it can live in other processes as well, then maybe it's easier to use choreography because you can then take it and plug it into different places easier. On the other hand, if you have a business logic that you can define in a flowchart, then that's when you should start thinking about orchestration. Also, if you have services that are closely related, that usually go together in a certain order, then there's no point in trying to do that in an event-driven way. You might as well put them in an orchestration. And if you want to stay in REST, you don't want to deal with the complexity of eventing and different event formats and different event types, then maybe orchestration is a good solution. And it's not an either-or solution either. You can also have a hybrid approach where for closely related services, you can have orchestration in a bound context. And then this bounded context can be communicating with other bounded contexts using events. In this model, you are using orchestration, but each orchestration talks to the other orchestrations using choreography or events. All right, so this concludes the discussion of choreography versus orchestration. Now let's look at the landscape. What kind of tools and services we have in this area? Now for choreography, for event-driven systems, they've been around for a long time. So if you're running on Azure or AWS or Google Cloud, there's a lot of options like EventBridge and EventGrid, and on Google Cloud, EventArc. And if you want to stay in open source, there are projects like Kafka or other projects like Solus pops up. So there's a lot of choice here. Now, orchestration is relatively new, but there's, again, quite a bit of choice there. So on AWS, there's step functions. On Azure, there's logic apps. And on Google Cloud, there's workflows and Cloud Composer. I would say workflows is for more about orchestrating services, where Cloud Composer is more about orchestrating data. And there's also open source solutions like Apache Airflow that the Cloud Composer is based on. And last but not least, there is a serverless workflow specification. This is a spec from CNCF, and there's a working group that's trying to come up with a workflow specification that defines how the workflows are defined and how they're executed. So it's something to watch for as well. All right, Now let's zoom into orchestration, because event-driven systems, I feel like most people know about it, but let's actually look at orchestration, and let's look at Google Cloud's workflows, which is an orchestration service, and see what it provides for us in terms of orchestration tools. Now, what is workflows? Workflows, it's a service from Google Cloud, and it tries to orchestrate and integrate different services. First, it can orchestrate the serverless compute solutions. So if you're running code on Cloud Functions, if you are running containers with Cloud Run, or if you are running applications on App Engine, you can put them in an orchestration in workflows. You can also include any Google APIs. So any Google Cloud APIs or any Google APIs such as Gmail or Maps, anything that you can call publicly with HTTP, you can include in your workflow. And on top of that, you can also include external APIs. So if you have an external API that you want to call, like SendGrid or Twitter or something like that, you can include those API calls in your orchestration as well. So workflows tries to bring you a unified platform, basically, to orchestrate all these different types of services and APIs. Now, how do you define your workflow in workflows? You do it through YAML or JSON. So for example, in this case, let's say we have 3 services: payment processor, shipper, and notifier. These are Cloud Run services and Cloud Function services. And you want to call them in this order. So what you do is you create a YAML file. In this YAML file, you define 3 steps: process payments, ship items, and notify user. You can call them whatever you want. Then you define what you call in each step. So in process payment, you're calling the Cloud Run service. So that's the URL of the Cloud Run service, and you're making an HTTP post. And the input of the HTTP post is the payment details that you pass into your workflow. And then from that call, you get a result back, and you can capture that result in process results. And then you can pass that result to the next step, ship items, and so on and so forth. So you can see how we can build workflows using this YAML or JSON logic. So workflows provides the steps that I show you. So you can define any kind of steps in any order you like. It includes serverless pause. So let's imagine you're calling your steps, and at some point you want to stop and take a wait for an hour or more. You can add that as a step. And it also provides passing variables between steps. So everything that you want to pass from one step to another step is possible. And then once you receive results from a step, you can do light JSON parsing on those results. So you can receive the result from a step, and you can pick the JSON and pick the certain elements of the JSON if you like. On top of this, it includes errors and retries. So for example, if you have a step and you want to apply an error policy so that, if the payment fails, you want to retry 5 times, but you want to do this in an exponentially back-off kind of way, you can do that. You can even route your workflows to different services depending on the outcome of your service. So for example, if the shipper is successful, it returns with HTTP 400, for example, you can send the result to a notifier service. But if it fails with some other HTTP error, then you can send the result to a pager service and maybe let your support people know that the service failed. It also allows you to do conditionals. So for example, you want to read the inventory from a database and check some result to see if you're in stock or out of stock. So you can do that check within workflows. You don't have to write code. You just define it in your workflows. And then once you're out of stock, maybe you want to make a call to a supplier API, which is a third-party API, and order more stock. You can do that from workflows. So you can see how flexible workflows is with conditionals and third-party calls. And other useful features of workflows is sub-workflows. You can think of sub-workflows as methods that you can define, and then once they're defined, they can be used in multiple workflows. And we also try to make it really easy to connect to different Google Cloud services. So instead of you trying to create the HTTP request from the workflow, we give you a connector, which is an easier way to connect to different Google Cloud services. So how do you deploy, execute, and manage workflows? You can do it from command line. So this is how you deploy. Once it's deployed, you execute with this command. And finally, as it's executing, you can see the result again from command line if you like. Or if you prefer UI, you can take a look at your workflow in the UI in Google Cloud Console. So you can see here that we have the YAML on the left. And then you also get a visualization of your workflow on the right. And then from here, you can execute your workflow, and you can also see the results of workflow all from the UI. And you can do all of this, by the way, from code as well. So if you have some cloud function, for example, that can trigger a workflow, that is certainly possible. All right, so this is what you get with Google Cloud Workflows. Now, in the last part of the talk, I want to talk about a case study. So we wrote an app called Pika Daily, which is a picture sharing app that shows how to use Google Cloud technologies. And we initially wrote this in an event-driven way. And then recently we refactored it and we wrote it in an orchestrated way. So I want to talk about this application, and I want to show you some of the lessons that we learned as we made this transformation. So this Pika Daily photo sharing application, there's a link. It's part of a workshop actually. And if you go to this link, you can see the workshop and you can build this app yourself if you like. But basically in this app, you upload pictures. And once you upload the pictures, we use Vision API to extract the labels out of these pictures. And we also extract the dominant color of this picture. So which color is dominant in this picture. And then we display it to the user. So you can see here, for example, we have pictures, and under each picture, there's the label of the picture. So it tells us what the picture is about. And around the picture, there's a border as well that tells us the dominant color in the picture. Now, the way we designed this is that this was the initial design, event-driven design. And in this design, we have users uploading pictures to App Engine. So this is the front end. Then the picture goes to a Google Cloud Storage, which is a place to save any kind of files. And then once it's uploaded there, that triggers bunch of events. The first event goes to a cloud function called image analysis. This receives the image creation event, and it says, okay, let me analyze this picture. It uses a Vision API to do that. And then it saves the analysis results into Cloud Firestore. The second event goes to thumbnail service, which is a Cloud Run service that receives the image and it resizes the image to a smaller form. Then there's a third service that gets triggered on a schedule, and it goes and fetches the 4 latest images from the bucket and creates a collage out of those images, so a combination of those images. And finally, the last service, the image garbage collector service, receives image deletion events. And when it gets notified that the image is deleted, it will do a cleanup after the image. So you can see that this whole thing is event-driven. Image creation or deletion triggers all the services, but they don't really know about each other. They don't really care about each other. Everything just works in kind of like a choreography. Now, we rewrote this using workflows. And in this model, what we did is we changed our code and we kind of changed our services, and we let workflow drive the whole process. So what happens in this case is that the user still uploads the picture to the App Engine front end. This goes to the pictures bucket. And then this triggers the file creation and deletion events just like before. But then a cloud function picks that up and it just passes to a workflow. So this whole flowchart you see here, it's workflow doing the work. So workflow checks whether the event type is object deletion or object finalize. And if it's object finalized, it makes a call to the Vision API. It transforms the data by calling a cloud function and determines if the image is safe or not. Then it stores the metadata to Cloud Firestore. Again, this is workflows doing the work, not code. And finally, it makes a call to thumbnail service and the collage service by calling Cloud Run services. Now, if the image is deleted, there's a separate branch. And in this case, we delete the image data from thumbnails and also from the database. Now, in this model, as you can see, there's workflows doing some of the work. But then in some cases, workflows can call other services like the thumbnail service and the collage service. But the whole process is very, very, very straightforward. You can see the logic here. This whole logic is captured. You can see it. You can visualize it in the UI. And you can see when workflow does the work. You can see when workflow makes a call to an external service. So these are the different things about event-driven versus workflow. Now, once we made this transformation, we learned some lessons. So let me share those with you. First of all, when we went from event-driven to workflows, we went from multiple different event types. There we actually had 3 different event types that we had to deal with. So we went from parsing 3 different event types to simple HTTP calls. And that was quite refreshing because we didn't have to deal with all these different eventing formats. Secondly, we got rid of a bunch of code. As I mentioned, we didn't have to deal with events, so we didn't have to parse them. We didn't have to have a function to do image analysis. We could instead call the Vision API directly from workflows. We didn't have to have a garbage collection service because we can delete the images and we can delete the metadata of the images from workflows directly. So we had less code to deal with. We also had less setup because we didn't have eventing to set up. So we didn't have to set up PubSub. We didn't have to set up Cloud Scheduler. We didn't have to set up no event arc. All we had to worry about is to set up workflow. And then with that, basically the setup ended up being much less than before. And the error handling became really easy because in workflow, if something failed, you would see it right away. We didn't have to look at logs or we didn't have to figure it out. Workflow would tell us execution failed and we could see in exactly what step it failed. And then if we had to apply error handling, again, we didn't have to do it in our code. We could do it in workflows. So that was really useful as well. On the other hand, workflow was a new service to learn with its quirks and limited documentation. So it's something that we had to spend time in learning. Also, since we got rid of a bunch of code, we had to change those codes and convert them into YAML definitions in the workflow, right? So instead of doing Vision API call, for example, in Node.js, we were doing Vision API calls with HTTP from workflow, which was good because it was less work for us, but we had to define that in YAML. So it's a trade-off, basically. You have code versus YAML, and now sometimes converting code into YAML is not that easy. And also in workflow, there's a single YAML file. So trying to do too much in YAML, it might be basically too much for a single YAML file. Debugging, testing, and logging in workflow is quite early in early stages, and there's no IDE support. So the way we worked is that basically whenever we change something, we change the workflow and we deployed it. And then that's when we would see if there's a problem. I think debugging and testing will get better as we go along, but as of today, it's not like code, for example, where you can just write unit tests. You have to actually change the workflow, deploy it, and see what happens in order to be able to debug it and test it. We also lost a little bit of parallelism with workflows because everything in workflows as of today is sequential, although we are trying to add parallel workflow steps soon. But as of today, it's sequential, so that means we had to do one thing after another, right? Whereas in event-driven systems, you don't really need to wait for anything. You can just emit events whenever you want and respond to events whenever you want. So we lost a little bit of flexibility that comes with eventing, but at the same time, we got a lot of structure to how things run and how things are defined. And for me, the most important point is that we have a central place now where we can actually see our workflow and visualize it. And if something doesn't work, it's very obvious where it doesn't work. So for me, these are the main gains from workflows. All right, so this concludes my talk. If you want to learn more about workflows, it's cloud.google.com/workflows. If you want to do the workshop and build the application in an event-driven way and later convert it into an orchestrated way, I urge you to check out our Pika Daily Serverless Workshop, and the link is here. And if you want to check out the code, everything is open source. So that's the GitHub link for the code. And if you want to reach out to me, feel free to send me a message on Twitter. I'll be happy to answer your calls. Thanks a lot for listening to my talk. And yeah, thanks very much.
Awesome. Hello. I hope you can hear me this time around. I might have forgotten to unmute myself because I didn't have my coffee in the morning. So welcome to Cloud DevOps and SRE for DevFest 2021. And I know what you're thinking is DevFest 2022. Why is it called DevFest 2021? Well, that's because DevFest usually runs in October and we were a bit late with it. So we just called it 2021 and 2022 is coming later on in the year. Awesome. So today we've got two talks. The first one you've already heard. And next up we have Dave Mason. Let's just bring you onto the stream. Hiya.
Good morning. How are you doing?
Yeah, not bad. How about yourself?
Yeah, very well, thank you. Shall I just get straight into it?
You can do indeed. Yeah. Do you want to share your screen? Can I do
Yeah, we'll do.
screen? Awesome. Yeah, can see that.
Can see that. Okay.
Cool.
Great. Okay. So, good morning. I'm Dave Mason, and I'm a principal consultant at InfinityWorks. I've been in software engineering for around 20 years now, formerly specializing in .NET development, but for the past few years, more Node.js. I'm also experienced with public cloud architecture. I was originally on AWS, then made the transition to GCP around 2018. So I just want to give you a very quick overview of who InfinityWorks are and what we do. So we're now part of the Accenture Group. We're a UK digital engineering company, and we specialize in using full stack, cloud native and data-driven approaches. So we're effectively full stack engineers, cloud architects, designers, and data specialists, and work with our customers to deliver immediate value and long-term strategic change through digital transformation. Now, before I get started with the talk, I'm going to make a bit of an assumption that you're already familiar with serverless technology and about the benefits versus infrastructure as a service or self-hosted solutions. So I'm not going to go into a lot of detail on that. However, if you are interested in my opinions on this, then do feel free to reach out to me. I'm always happy to share them. And I'm available on either LinkedIn or Twitter, and you can see my details there on the slide. What I want to do instead is take you through a specific use case and see how we've used serverless technology to solve a specific problem. So here's the problem we were trying to solve. So I was working with a publisher who is best known for montage videos posted onto social media, mostly comprising of stitched together self-shot footage from their massive online community. Once submitted, the videos would be moderated, licensed, and added to a database of user-submitted content. A video editing team would then use this resource to create the montages on their iMacs before posting them directly to social. However, due to the feed-based, fresh content nature of social, once a video got to around 3 days old, it became pretty much undiscoverable. What this meant was that the vast majority of their highly popular content was unavailable to their following, and crucially, that meant that they couldn't monetize it. To solve this issue, they decided to create their own platform in the form of a video streaming app where their content could be browsed, searched, and suggested to their users. So what we needed to do was host and populate an API that makes all the videos posted to social easily discoverable to the app. So the challenge here was that there was no content management of the video montages created by the video editors. So they were simply uploaded to the social platforms directly and left in folders on their hard drives. A small amount of metadata would be added to the video and upload, but it really wasn't much. Now, the right solution here would be to introduce a content management system that the video editors could use, which would push the metadata via automated integrations to the various social platforms, as well as the publisher's own platform. And then we could integrate the app with it. However, due to the speed that we needed, that a solution was required, as well as a lack of appetite from the video editing team to amend their existing processes, what we needed was a solution that would deliver the same end result, but more quickly and with no friction for the already incredibly busy video editing team. So at a very high level, this is the solution that we came up with. So we found that Facebook exposes some useful management APIs for a page or for an organization's video library. This allowed us to effectively scrape what had been uploaded at a regular interval, downloading the video asset as well as any metadata that had been added by the video editors, which tended to be a title, the date the video that was published, and a playlist that the video had been added to. Now, due to a pre-existing commercial agreement, we needed to use a set provider for uploading, transcoding, and streaming the video itself. So that was the first step of the process. Following successful processing, we needed to enhance the metadata of the video to make it as discoverable as possible. We were keen to automate this as much as we could, though we're willing to accept some manual input by content editors. Finally, the metadata would be added to a database and made available to the app via an API, at which point the video should be easily discoverable by the app's end users. So after a few sessions around a whiteboard and a lot of discovery work, this was the design that we came up with. The whole process will be kicked off using a cron job, which could be done in a serverless fashion using Cloud Scheduler, allowing us to poll the Facebook API on a regular configurable basis. The download would be carried out by a cloud function, which would then trigger messages to two pub/sub queues, one that would kick off the cloud functions for uploading to the third-party streaming provider and then listening to the processing result via a webhook, and another for triggering the automated metadata generation using Google's Video Intelligence API. The results of each of these processes were stored in a shared database hosted using Cloud SQL. Separate cloud functions, which were also triggered by Cloud Scheduler, would be responsible for generating further ongoing metadata, such as calculating engagement scores and curating daily bundles of popular videos to be push notified to users via the app. This was a few years ago. We used Stackdriver, as it was known at the time, now known as Google Cloud's Operations Suite. We used that for logging, monitoring, and alerting. This was particularly easy to integrate and gave us detailed, easily searchable logs, real-time dashboards, and a carefully crafted alerting strategy to hopefully ensure that I only get woken in the middle of the night if I actually have to be. It's also worth noting that we created a small React application for manual editing of video metadata, as well as the ability to manually remove videos from the app. And that was hosted in Google Kubernetes Engine. I'd also like to call out at this point that this project, shortly after it was delivered, a new product called, well, not so new these days, but Cloud Run moved into general availability. If you are considering hosting serverless microservices, Cloud Run is definitely worth considering, as well as Cloud Functions. Again, if that's, I'm not going to go into detail on that, but if it's something that you'd like to know more about, then feel free to reach out. What I'm going to do now is dig into each of these GCP technologies that we did use in a bit more detail, to hopefully give you a better understanding of why we chose them, and when they might be appropriate for solutions that you're working on in future. So we'll start with Cloud Scheduler. So in a nutshell, it's Google Cloud Platform's enterprise-grade cron job scheduler. You can schedule pretty much anything with it. You can target either the pub/sub messaging service and send a specific message, a HTTP endpoint with a specific URL and headers, or a service-specific endpoint in App Engine. Personally, I particularly like the idea of this being serverless. I've been around a while, and over the years, I've seen a lot of systems that have a sort of single server running cron tab, which quickly becomes a single point of failure. By making this point in the process serverless, the risk of things simply not running when they're supposed to pretty much disappears. It's worth keeping in mind that scheduler guarantees at least once delivery, meaning that you should expect in some cases that scheduler is going to fire multiple times, and you should build your listeners with that expectation. I'll be honest though, I've been using it for a while. I've never, to my knowledge, seen that actually happen. But obviously that means that's going to happen next week now. An extensive retry configuration can be set up with back-off maximum retries and retry duration values. And it does log out to Operations Suite. And very usefully, it has time zone support. So the jobs can be triggered relative to a specific location's time. And interestingly, here's a true story from this project. We did find that at the time, there was actually no support for Cloud Scheduler in the Google Cloud Terraform provider. However, not one to be deterred, one of my senior engineers ended up collaborating in the open source community with another software engineer based in Canada, who he met on Stack Overflow because he had the same problem. Together, they built Cloud Scheduler support in the Google Cloud Terraform provider and got it released as an update once the PR was accepted. So if you ever do find yourself using the Terraform provider for Cloud Scheduler, maybe look up a guy called David Harrison on LinkedIn and pop him a little thank you message. Interaction between our functions was coordinated using PubSub. PubSub is, unsurprisingly, a publisher-subscriber service that allows other services to communicate asynchronously. I won't go into the benefits of decoupled architecture as part of this talk, but if it's not something you're familiar with, then it's well worth learning about this particular architectural pattern. PubSub is essentially a message queue. And can be considered as a serverless alternative to popular products such as Rabbit and, I guess, less so Kafka. Our implementation of PubSub was for a parallel processing workflow, but it can also be used for data streaming and ingestion. Common use cases include ingesting user interaction and server events, real-time event distribution, replicating data amongst databases, and data streaming from IoT devices. For us, it was the most sensible method of interfunction communication. Firstly, it meant that the communication was sort of fire and forget, so we didn't end up with one function waiting for another function to complete. Secondly, it meant that if a function failed, the message that triggered it was not lost and could be retried or replayed. Retry can be configured on a per queue basis, and you can specify a dead letter queue for messages to be written to after a configurable number of failures. It's also got a really useful replay feature. Normally, once a message has been acknowledged by a subscription, the message is gone forever for that subscription. However, if you configure message retention, you have the option to go back to a certain point in time and replay all the messages published since then. This can be useful in production outage scenarios where you need to rebuild state from a set of transactions, though it is fiddly to do. So I'd recommend this is something that you practice with before you inevitably end up having to do it at 2 a.m. during a production outage, and do make sure that the steps are included in your support playbook. The actual business logic of the process was all written as cloud functions using Node.js as our development language. Cloud functions are one of GCP solutions for serverless computing. They're often compared to AWS Lambda or Azure functions. Cloud functions are the youngest of the three. They've been generally available since July 2018. Their runtime support, obviously Node, which is up to version 16 now, Python up to 3.9, Go up to 1.16, Java 11, .NET Core 3.1, Ruby 2.7, and PHP 7.4. So they've got really good runtime coverage, and that list gets added to on a regular basis. So even if it doesn't support your specific runtime, do keep an eye on it. Alternatively, as I mentioned before, Cloud Run will run your own Docker image in a similar fashion to a cloud function. So that's another way around that specific limitation. Much like most serverless offerings, Cloud Functions are stateless, so you can't rely on in-memory values from previous invocations in future invocations. Each time a function is triggered, it creates a new instance of the function, effectively creating auto-scaling functionality if multiple concurrent triggers occur. You can set maximum and minimum instance limits for each function. That's good for controlling costs, controlling external dependency bottlenecks, and trying to work around the infamous cold start issue that seems to plague all serverless function offerings. Cloud Functions are configured by memory up to a maximum of 8 gig. Interestingly, the available CPU is tied to the amount of memory you configure your function to have. So to give you an example, if you give your function 1 gigabyte of RAM, it will get a 200 megahertz CPU. If you give it 8 gig of RAM, it will get a 4.8 gigahertz CPU. And there's a sliding scale between those 2 points. Now, clearly, as these values increase, the cost of each individual function invocation increases. So it's really worth thinking carefully about what you actually need, and then monitoring the functions once live to ensure they're sufficiently utilized without slowing down due to lack of available resources. They support timeouts in seconds up to a maximum of 9 minutes, though it's 1 minute by default, so do watch out for that one. They support environment variables for build time configuration and service account permissions, so you have fine-grained control over which other GCP resources the Cloud Function has access to. Cloud Functions log to cloud logging by default by writing to standard out, which makes it very easy to get detailed information about what your Cloud Function has done in an error scenario or otherwise. They also report invocations and execution status as a standard metric, which makes it easy to build dashboards and alerts based off those metrics. They can communicate with a number of different GCP services, including Cloud SQL, Cloud Storage, and App Engine. And they can be connected to your VPC, so they can access services internal to your private cloud network, such as an API in Kubernetes engine or memory store for a Redis cache. They can be triggered by multiple types of events, including HTTP calls, pub/sub messages, and cloud storage events. So in our use case, this enabled us to create the process as a series of serverless microservices orchestrated using HTTP calls from Cloud Scheduler, external webhooks, and pub/sub messages sent between services. So once we'd figured out the detail of the process, we needed to understand how to slice up the functionality into different functions. As with any microservice environment, this is more of an art than a science, and what works in your specific situation isn't necessarily going to work in others. I was fairly pleased with the result that we came up with when we did this design, so I'll talk you through it to give you a frame of reference for technical designs you might be doing in the future. So our rules of thumb for the scope of each Cloud Function were that it should have one trigger, one specific purpose, and one external integration. So for example, we could have written a Cloud Function that pulled down the video and the metadata from Facebook and uploaded it to the third-party streaming provider, but this would not have satisfied our rules. Now, clearly there's a trade-off between function complexity and the amount of infrastructure you have to manage. So again, it's important to think about what feels right to you in the specific context of your project. So I'll take you through the scope of each of the functions that we did define in a bit more detail. So the first was just fetch Facebook videos. That was triggered by Cloud Scheduler, and its function was to download the video and metadata from Facebook, store the video temporarily in a bucket to await processing, and pass the video URL and metadata onto a pub/sub queue. So that one's external integration was Facebook. We then had Cloudflare Upload, which is our video host. So that was triggered by a pub/sub queue, and its function was to process the message from the queue and send an upload request for the Cloudflare API. So that had a Cloudflare external integration. And then similarly, it was the Cloudflare webhook. So that was an HTTP trigger, and that received processing status messages and updated our video metadata accordingly. And then we get on to the video metadata enhancement functions. So we had video intelligence that was triggered by a pub/sub queue. And what it did was it passed the video to Google's video intelligence API and stored the return tags in our own video metadata. We had an engagement function, which was triggered by Cloud Scheduler. That function's job was to pull down engagement metrics from Facebook for videos, execute a proprietary algorithm to calculate an engagement score, and update our video metadata. And finally, we had our bundle creation function. So that was triggered by Cloud Scheduler. Its function was to use engagement scores for the previous day's published videos to automatically curate a list of the top 10 trending videos and create the day's bundles in the database. So referring back to my earlier point, you could probably make quite a strong case for engagement and bundle creation being done in the same service or in the same cloud function. And that wouldn't be wrong per se. On the balance of things, we decided that the functionality was different enough, and the fact that they ran on different schedules was enough to warrant two separate cloud functions, but ultimately it would have worked fine either way. So now that I've talked you through the core functionality of the solution, there are a few other technologies and approaches that we used as part of this that I think were worth mentioning. So the first of these was Video Intelligence API. So this is a service provided by Google that has a set of pre-trained machine learning models that can recognize over 20,000 objects, places, and actions in a video. Having looked at the quality of the metadata being provided by the video editing team at the publisher, we didn't feel it was rich enough to power features like video categorization and search. So we used the opportunity to look at this service, and I have to say we were very impressed by the results. We primarily used it for object tagging. So for example, if a video had a dog in it, Video Intelligence would recognize this and return that tag. But also there was a sort of fully formed taxonomy to the tag data that it returns. So we would usually get an animal tag back as a sort of parent tag. And if it was able to recognize the breed, we would sometimes get that back as well. So if required, I'd have considered using that to create like a multi-layered category structure for the content, which might be useful if you were building like an SEO-friendly website and wanted to improve cross-linking. There's some other interesting functionality that it offers. It does shot change detection, text detection and abstraction, explicit content detection, automated closed captioning and subtitles, logo and celebrity recognition, face detection, and person detection with pose estimation. No, I've never tried that one out. The use cases for this kind of functionality are endless. One of the most popular ones is automated content moderation using the explicit content detection. However, from experience, I'd be very, very careful with that one. Inevitably, it's not going to pick up 100%. And so if you're catering to a sensitive audience, I'd be very wary about using this to replace moderation by human beings. And also be wary of the costs of using this API, which can quickly rack up if you've got a lot of video to analyze. So for example, the cost of object tracking is 15 cents per minute. We were dealing with around 4,000 minutes of video a month. So it incurred the not insignificant cost of around $600 every month. Now, I appreciate that's fairly small fry in the context of most cloud bills, but it is worth keeping in mind before you start playing around with it. On the continuous integration side of things, although it's absolutely possible to do everything I've described from the GCP console, by creating resources manually or even from the CLI using Cloud Shell, that's rarely the right way to go. Having a fully documented infrastructure that's controlled by a code review process in the same way that your application sources has many benefits. We were keen to ensure that we went down this route, not least to prevent configuration drift, have a fully audited set of cloud resources, and to create a great developer experience. We chose Terraform as our infrastructure as code language, as we already had Terraform experience within the team, and GCP has a very actively maintained Terraform provider. All infrastructure was created as Terraform, and then we used the Terraform plan process to check what changes, if any, would be made by the current branch. The Terraform plan itself was then written back to the pull request as a comment to ensure it was included as part of the review. Once merged in, Terraform plan would be run again on the main branch, at which point a manual approval was required before the plan was applied to GCP. Now, we use Circle CI as our build tool, mainly due to it already being well established as part of the publisher's development process in other areas. Given the chance again, I'd certainly take a look at Cloud Build, GCP CI tool. Integration with GCP hosted solutions would just be a lot simpler. For deploying the cloud functions, we went through 3 steps. So the code would be compiled with Webpack and then zipped up. The zip file itself would be uploaded into a temporary location in cloud storage, and it would be given a file name that included a hash of the content of the cloud function to ensure that the file name updated every time that the code was changed. The Terraform would then reference this file name as an environment variable. So when a change had occurred, Terraform would recognize this and include the update as part of its plan. Pub subtopics, Cloud Scheduler, and Cloud SQL could just be written declaratively using standard Terraform syntax. We deployed pub subtopics, cloud functions, and scheduler jobs from Circle CI. Yeah, we found that worked very well for us. The final element of the solution that I want to talk you through is Cloud Operations Suite. So defining an appropriate logging, monitoring, and alerting strategy is essential for the successful operation of a system like this. Although serverless cloud infrastructure takes away a lot of the headaches associated with on-premise or infrastructure as a service-based solutions, there's still plenty that can and probably will go wrong due to service capacity, bugs in application code, unexpected data from external systems. It's critical that these sorts of issues are identified and resolved as quickly as possible. And if you get this part right, that's exactly what will happen. So we were using cloud logging that will capture content from standard out, but we found that using Winston, which is a popular Node.js logger, combined with Google Cloud's Winston logger as a transport, gave us much richer log messages. We then used a combination of logs and metrics generated by other resources to create real-time dashboards. So we got a nice sort of single pane of glass view. And that, for example, there was a graph that had a bar chart that just showed us every single time there was a failure from a cloud function. And then we used that to build an alerting policy as well. So we just alerted to Slack, and then anyone that needed it just had the Slack app on their phone and set that channel to alert every time a message was posted. I'm pleased to report that we got this project from ideation through discovery, development, testing, and eventually in production within 2 months, with 4 engineers working on it. That included the Dockerized development environment, CI/CD, all cloud infrastructure created, and all functions built, including all third-party API integrations. We continue to iterate on the project, adding in support for personalized recommendations, enhanced search, suggested search, and user customizable category filtering. I hope you find this useful. If there is any time left, I'm happy to field any questions, and thanks for listening.
Hi, thanks, Dave, for a brilliant talk. I don't believe we have any more questions, and thank you for your time today.
No problem at all. It was a pleasure. Take care.
Take care. Cool. So next up, we have a coffee break. We will be returning at 12 p.m. So I'll see you guys then. Thank you. Hello, hello. Hope everyone is back nice and caffeinated, ready to start the next session. So next up, we have live streaming with Google Cloud from Wayne Louis, I believe. I'm sorry if I pronounced that wrong. And cloud workflows, what's new in serverless orchestration and automation. Awesome. So if I just bring Wayne onto the screen. How are you doing?
Doing good. Hey, Kartik.
Awesome. So on your bio, it says you're from Singapore. Are you currently there? Yeah.
Yes, I'm currently in Singapore. It's sunny all
what
year
time is it?
round. In fact, it's actually quite hot right now, even though it's 8
hot.
p.m. In my local time.
It's 8 p.m. and it's hot.
Right.
How hot is it? Do you know? Is it like 20 degrees?
I suppose I could check my. Well, in general, it's the humidity that's making me feel
Yeah.
the very hot feeling. I think it
Yeah.
should be close to 30 right now, if I'm not wrong. Probably have to 32 degrees.
32 degrees. Oh my god. I wouldn't be able to handle that heat. Well, awesome. I'll let you get started with your talk then. I'll just add your screen. Awesome. Cool.
Yep, I see it there. Thanks, Kartik. All right, so let's get this session started. So very excited to be here to be speaking with all of you and sharing with you a project I've been working on over the last year. But the important part here is I want to share this project I've done as sort of a case study to let you understand, and perhaps if you are new to Google Cloud, what you can use in Google Cloud to build an application, be it for yourself or be it for a group that you represent. All right, so let's get started. All right, so I wanted to talk a little bit about the problem statement, why I went into, why did I have this problem of this live streaming problem? We have to create a solution for that. And we'll tie it back to what solution we are creating on GCP. Okay, so as you guys know, there is this ongoing pandemic situation. And as a event organizer in Singapore, I do organize activities for my local communities as well. And when the pandemic hit, of course, the restrictions came in. We're not supposed to host physical events. What this meant was that we had to look into shifting our activities online. And this meant doing something like this, a live stream. But even with live streams, we realized that there were some issues that we faced, or rather criteria that we want to fulfill with our live streaming solution. Being that because this format was entirely new to us as well as our guests, we wanted a solution that is easy to use. And because we are self-funded, so we wanted to have an affordable option if possible. And lastly, we were collaborating with multiple groups in our region. Instead of just looking at streaming to perhaps a YouTube channel or Facebook page, we wanted to explore being able to stream to, let's say, 10 different sources at once, allowing us to be able to collaborate, with our different partners much more closely, for each of our live stream. So we had this special criteria, and we decided to look into what solutions we can use to solve this problem, this live streaming problem. Okay, and as an engineer, of course, we'll think about building a solution, but the important thing is we didn't want to reinvent the wheel. So we started looking into solutions out there. Well, what about dedicated solutions like using YouTube or Facebook Live or Twitch? We found that solutions like this, dedicated solutions like this, while we could argue that it's somewhat easy to use if we are used to it, it's definitely affordable. Most of these are free to use from the start. But because the infrastructure that they provide are for their own business, it didn't make sense that dedicated solutions will allow you to stream to other systems or businesses out there. For example, it's not going to be a simple task to stream from Facebook to YouTube. So we felt that this wasn't a solution that met all three of our criteria at once. Then we started looking around, what about free open source solutions like OBS Studio? And while it was indeed free and we could stream to multiple destinations like multiple YouTube and multiple Facebook pages, we thought that it wasn't very easy to use. Like if you can take a look at this interface over here, it didn't feel like something that I could immediately use to create a stream and be able to quickly onboard my guest for the live stream. So we felt this might not be a very user-friendly solution. It was more for perhaps for hobbyists who want to look very deeply into how to create something that was very customized for themselves. Okay, so we realized that even for solutions like OBS Studio couldn't meet our needs. What if we go for a solution, if we pay a little bit for the solution, but we should get most of the criteria fulfilled? So that's where we look into StreamYard, which is actually what we are using for this live stream today. And what we found was that they do support being able to stream to multiple destinations at once. And it was to some extent affordable. The lower subscription plans were not as highly priced, as compared, let's say, a much more commercial solution out there. And definitely it was easy to use. But one big problem we faced was the balance between affordability and our criteria to stream to multiple destinations. If we wanted to stream to more destinations, we need to pay for a higher subscription plan. So this created a problem where we're limited by a smaller amount of destinations if we want to keep our costs low. So we realized this wasn't exactly the solution, almost the solution we need, but not exactly it. All right. So we have a dilemma over here. We couldn't really find a solution out there that solved our problem. But building our own solution is as if we are building our own product for a startup. It seems a little bit too much for a not-for-profit organization that we're running. So we started thinking, what if we could pick out one of the three solutions from earlier on, create a wrapper around it, perhaps using GCP, and use it to solve for all the three criteria that we set forth. All right. So if we just improve the current solution? And that's what we did. We re-look at StreamYard again. And what we realized was that we could stream from StreamYard to a custom RTMP server. And theoretically, it would mean that we could host this server on Google Cloud. And from there, host the application that allows us to multiplex to even more channels. Okay, this allows us to be able to use the easy-to-use interface of StreamYard, as well as keeping to the lower subscription plan within StreamYard, while affording us the ability to be able to multiplex to multiple channels. All right, so we decided to went with this. Of course, we, as engineers, we want to make sure we have the best solutions. We don't want to vendor lock ourselves. So we made sure that the source, we assume that it could come from either StreamYard or Zoom or Meet. As long as it's a valid source, RTMP source, we will accept it. Okay, so this is the solution we went with. But we're not interested in this high level look at it. We want to understand the inner workings of it. How exactly did we get this out? All right, so let's go into the house of this solution. All right, so let's take a look at the architectural diagram that I drew up, for this solution, and we'll slowly replace each portion by the relevant managed tool in GCP to give you some appreciation on what we used to build the application here. Okay, so we knew that we needed a server, host a server to be able to relay this stream and multiplex it to all these different destinations. Now, this means we have to host this application using one of the many different tools in GCP, right? So we can immediately translate that into several questions that we have to answer. For example, should I use a serverless tool like Cloud Run, or should I use something like a IaaS solution like Compute Engine, getting my own virtual machine? So it's very important you ask yourself these questions before you select the tool, because there are different trade-offs that come along with it, all right? But in our case, it was actually very easy for us to answer. Because what we realized was that Compute Engine was the correct answer because it was the only tool that supported RTMP stream, unlike the serverless solutions. So this was a very simple choice for us to make. We decided to just go with getting our own virtual machine via Compute Engine and just host our solution on that virtual machine. Okay, very clear cut. So let's replace this component in the middle over here. Okay, give me a moment. So let's replace it. So you can see over here that I have a virtual machine instance here. On the bottom here, I'm going to start indicating the different tools that we will be using for this solution, just to give you a sense of how many different tools we tried to explore. Okay, so let's start off with this virtual machine instance. Well, what are we hosting on this virtual machine? Well, we are running a Nginx server with a RTMP module on top of it. Okay, so just to dive in very quickly, I don't want to talk about the entire Nginx server, but just to give you the direct context that you need, You can see over here, this highlighted portion, we have some templating engine that allows us to take this template and create an Nginx configuration, server configuration. And what will happen is that we'll render the multiple destinations that we want to relay to. So be it YouTube or Facebook. Over here, we also have a S-tunnel, which is a TLS tunneling service, allowing us to communicate with secure sources. For example, this is referring to RTMPS. For example, referring to Facebook, because Facebook only support RTMPS. YouTube does support RTMP. So this is similar to HTTP and HTTPS. Okay, there's also a node server, but it's not really related to this running of this service. We'll talk about it later on. Okay, so let's go back to our diagram over here. In theory, we have already solved our problem. Okay, we have a server that can help us multiplex and send a signal to all of these different services. But we should do more with this. Well, let's try and understand deeper what are the criteria or conditions that we should face. Okay, so we know that we have to expose the port 1935 for the RTMP stream. And some of you might already know what I'm going to talk about next. So of course, we need to start thinking about cloud network or networking services, essentially allowing us to set in the correct firewall rule to expose only this intended port to that intended IP range if it does apply. Okay, so not overtly exposing, whatever you don't have to. Okay, so that's one portion. What about other problems that we want to, or questions that I want to ask, in regards to this setup? If I have to create a virtual machine and pull the code, my Nginx configuration into this virtual machine manually, it's not very much automated. It's very clunky. Can I make it easier for myself to deploy this application? Okay, so how do I make it easier for myself to deploy? Well, one thing I can suggest is that if you're using a IaaS solution or you have your own virtual machine in GCP, I would suggest that you look towards using something that is called over here, which is Container Optimized OS. This essentially allows you to be able to supply a Docker image and use that Docker image to run a container on this server. So let's say if you run this Docker image, create a container on this server, it will run as the application that you need to, instead of having to manually shell into the virtual machine and run those individual setup instructions via your shell. All right, so over here you can see this is the configuration that's required. You can see that you have to provide some form of a address indicating to the virtual machine that they have to pull from this source, for that Docker image. Okay, and saying this, definitely you can use third-party solutions like Docker Hub to host your image. But one advice I'll give is this: if you want to use Docker images in your GCP application, be it in container optimized solutions over here, or serverless solutions like Cloud Run, which you also need the same thing, I would very much encourage that you use the container registry that is supported in GCP. All right. Okay, so just to pull it out and show you, we have another additional component, container registry, which supports us as our Docker image registry. This allows us to be able to host our own Docker images and use that, for our deployments, be it inside our virtual machine here or in Cloud Run if you need to. Okay, so it's also a lot easier to integrate, because for third-party solutions, you need to start thinking about things like access control. Okay, another question that some of you might be asking is, now that we have our image repository, we know we want to deploy this image, run it as a container on the virtual machine. But the question is, well, where am I supposed to build this image? Am I supposed to build it manually in my machine and push it up to my image registry? Well, you could do that, or you could make use of a CI/CD pipeline. This can be easily done in Google Cloud Platform using Cloud Build. Okay, to give you a simple demonstration of that, so I have over here configuration on what you can supply. In fact, this is code that you can commit together with in your code repository. The configuration indicating to Cloud Build what the pipeline should focus on. So you can see over here in this simple demo, I have a 2 stages to this build pipeline. the first stage from line 3 to line 6 over here, what I'm looking at is to build the node module. So I'll install the dependencies for my application first before looking at packaging them into a Docker image, as you see over here from line 8 to 16. Okay, so once I run this CI/CD pipeline, you can see on the right that this is the interface that will reflect, once the pipeline has successfully completed, or if it fails, it will be indicated here differently as well. So here you see a green check mark, but if it fails, it will become a red cross, right? And you can also get all the logs for each of the stages here. So giving you more opportunities in debugging your pipeline if it fails, all right? So a very, very useful tool indeed. And again, it's part of an ecosystem within GCP. So you don't have to look at using a third-party tool and look at integrating back to GCP or your other systems and worry about things like access control. Okay, so we're done with the part on setting up the Docker image. All right, another question that some of you might be asking, if I'm setting up an application in Google Cloud, I should think about secrets or configuration that I want to put within my application. Before I start my application, this should be added in my application. For example, a .env file. So that contributes to the environment variables you will run in your application. So some of you might be asking, when should I inject it? Where should I inject it? Well, my suggestion here is that you could use something like Secret Manager. So GCP has this other nifty tool called Secret Manager. It allows you to be able to save your secrets as well as your configuration. If you want to save it as a .env file that you can pull into your application later on, you can do that. That's what I did with some applications as well. Right, so you can use Secret Manager as you see over here. In the bottom over here is written as Secret Manager. And again, just to give you a very quick overview of the interface, Secret Manager itself is not just for you to be able to store your secrets as well as your configurations to use in the application. You can also do a lot of other nifty things like version control. Take, for example, if I have to support an older version of my client as well as a newer version, for different clients that I have. So since I have two versions of this application, it stands that the secrets might also differ. So I could support a version 9 for the older client and then the latest version for the newest one, right? And once the older client has been fully migrated to the new system, perhaps I can deprecate that older secret, once that's not required anymore and destroy the secret. So this allows me to fully deprecate that secret and not allow it to be, exposed in any other processes in the future. If someone tries to see this, they can't see it. These are older secrets that we don't really want to share. Even if it's expired, it could pose as a security risk, right? So you can actually play around with the different version control tools inside Secret Manager. It's very, very nifty, very, very useful. You can just use the JavaScript SDK, like in my case for a Node application. I believe they do have different SDKs for different languages as well. So very useful in terms of integrating with your application in getting your secrets and configuration. Okay, again, another tool within GCP's ecosystem. We're not moving out of it. It's a lot easier to set up things like access control, which are established in a bit. But in fact, I'm actually going to be talking about it right now, which is access control, because that's one big issue that some of you might be thinking about, for security purposes. If this virtual machine over here has an application that can talk to Secret Manager and get the secrets, how do I prevent, public users from, let's say, directly interfacing with Secret Manager and pulling the secrets into their own environment? So the important thing here is also access control, but in GCP, access control is done a lot more easily because all of these tools are in the same platform. Okay, so let me demonstrate why is it simple. Okay, so what you can do is add IAM into your setup. In fact, this is very standard in most of your projects. You will likely get to touch. You likely get to use IAM. Okay, and the important part is this. Let's say for my virtual machine, I'm running an application there. There will be definitely some form of identity I want to tie to the application. So in this case, you have a machine account here or a service account, which signifies as the identity for the application. And what you can do is that you can assign roles to this service account. So this, what it does is that it grants extra privileges to this role, to this service account. And this service account, being that application that I deploy, is able to do certain things, like in this case, able to pull the secrets from secret manager, allowing me to be able to inject those secrets, be it during the when I start up and initialize the application, or maybe I have a cron job that pulls that secret once in a while. All right, so you can use IAM to grant access control like that. In fact, very simply, without even have to worry about things like baking your secret keys into your virtual machine, or other weird hacks or workarounds like that. So very, very useful indeed. Okay, so we have a very basic setup for our application, but I want to expand my solution and make it better. If I'm running a live stream, sometimes I might be worried about what if, let's say, YouTube goes down or Facebook goes down. This might stand as a problem for me, where I might not have the, let's say, a backup MP4 file to be able to upload to my channel later on. Okay, so as I was thinking about expanding my solution, I started thinking, can I add a backup feature to this live streaming solution that I have over here? And that's where we decided to explore and add in cloud storage. And cloud storage is an object storage solution, allowing you to, within your application, if you need to upload files, for example, if I have a profile image feature, I can immediately just stick that image as my user uploads it and put it inside a private bucket. So this is what we did over here. Similarly, at the end of my live stream, I could look at creating an MP4 file and push it to my storage bucket, allowing me to be able to back up my stream consistently. So, I could use this for many different purposes. I could use it as a backup. I could use it to perhaps as downloading the files later for some other purposes, maybe uploading to other platforms later on. All right. So this allows me to fulfill another purpose in my application, making my my application even better. Okay. So just to demonstrate just to show the configuration very quickly, again, the Nginx server, I have a configuration allowing me to create that MP4 file after the stream has ended. And it will trigger some logic in my node server. So just now I mentioned about node server that I didn't look into yet. This is the node server. So some functionality in there allows you to be able to take that file and push it to the cloud storage, to my private bucket. All right. So this allows me to be able to get it inside this folder, as you see over here. And if I click into that video file, it should load up as an MP4 file in the browser. And given that, because I have the rights to view the bucket, I should be able to see the MP4 file load and run as a normal video. Okay, so this is just one usage of cloud storage. You could use it to store any other objects that you have as well, as files that you want to store, image files, just now as I gave the example. Okay, so we have gotten a very good sense of this entire application here. But what if or rather, some of you might be asking now, well, there's a lot of items I need to set up here. Just now I mentioned that I wanted to make this deployment of this application simpler by using a Docker image, containerization concepts essentially. But how can I deploy this simply with all these different tools integrated now? So this is where we started exploring another possible improvement. So infrastructure as code, which you can look into using things like tools like Terraform, or in the case of again, going back to the ecosystem, I could use something like Deployment Manager. So you can see over here, Deployment Manager. I can use it to set up all of my application and tools over here in one single click of a button. Okay, so this is what we mean by infrastructure as code, something very important for your DevOps team in your company, to set it up if you want to being able to set up multiple applications environments very, very quickly. Okay, so just to show you, this is the, of course, with Deployment Manager, you do have to provide the configuration. This is just a snippet of it. You can see over here, this is referring to the virtual machine that we want to bring up with the image details actually inside this configuration, as well as some network settings. But unfortunately, for Deployment Manager, it doesn't cover 100% of all the instructions I need. For example, being able to assign a role directly to a service account. So I have to implement certain special functionalities like that via shell script. But this still gives me that one-click effect where I could immediately just run that script and I'll have the entire application brought up. And if I need to bring it down, I'll just run the same script and bring it back down. So bring it up and down at different points of time. If I'm not running my live stream, I can use it as a way to save my money because I can bring it down and essentially not bear the cost of running that virtual machine and also all of the other tools. All right, so this is the entire solution that we built using, let's see over here, 1, 2, 3, 4, 5, 6, 7, 8, 9 different tools in Google Cloud Platform. In fact, you can look at using lesser tools or more tools depending on your needs and requirements in Google Cloud. And I'll touch on that a little bit more later on. All right, but just to show our solution did work, we ran it in one of our live streams, and you can see over here, we managed to successfully host 3, as in the live stream, and relay it to 3 different YouTube pages and 2 Facebook pages over here. So definitely a success in terms of our third criteria. And then we met, okay, so easy to use is already there. Multiple destinations is already there. How about being affordable? So the criteria of affordability was also identified that, we met it because you can see over here that for every single live stream that we run, we spend only around 76 cents for a 3-hour live stream. So this was something that definitely was good for us because we were running around 2 to 3 live streams a month. And definitely that doesn't match up to the upgrading of the subscription plan, to the next tier, or the entire cost essentially. Okay, so definitely affordable. Okay, so just one thing to add, if you're a new user of Google Cloud, definitely explore the free quota. Okay, so sometimes, even as a student, when I first get to use Google Cloud, sometimes I'm thinking about if I would be, charging, some cost of my credit card. And fortunately, I was able to take advantage of the free quota to host some of my applications for free, right? So do make sure you take note of the free quota. It's limited, by the way. Okay, so we've gone through our entire application. You can see over here many different categories of many different tools, 9 different tools as I mentioned just now. But I mentioned that you can look into using more tools if you wanted to. Well, one thing I didn't mention is telemetry. If you want to build a good production grade application, monitoring is always important. You want to know about if a system goes down, you want to be able to monitor what exactly happened and be able to debug and diagnose later on. You can also take a look at different creative features that you can create with other tools in Google Cloud. For example, speech-to-text API. What if I can use this to transcribe the backup videos that I created just now and use that to create subtitles, a VTT file, upload it to the different platforms, use it to create my subtitles for my videos. Okay, again, another creative feature that you can look into. Okay, so we've come to the end of that case study. I just want to, before I end off today's discussion, want to give some advice if you are looking at starting to use Google Cloud for the first time. Okay, so if you are new to Google Cloud, definitely what our advice is you should look for the online portals and see if there are events that might be relevant to your learning. And definitely for physical events, I know right now it's a bit hard to get into physical events, but definitely do sign up for those, especially when it's safe to do so. Yeah, so some of these physical events are the ones that I learned a lot from because I can interface with the experts directly. And definitely that this is very important. Do subscribe to Quick Labs, or I think now it's called Cloud Skills Boost. They sometimes do offer free codes, once in a while to allow you to try out Google Cloud for free. And what they do is they have a labs environment that allows you to use Google Cloud, not just in a sandbox, but actually using the environment. So you gain real life experience by going through their labs. So definitely this is a very good tip. I would say, go follow their Medium page or their Quick Labs account. And yeah, definitely do take note of your free quotas. And yeah, actually that's the end. So if there's any questions, I'll be happy to answer them. Or actually, I don't think there's enough time, but I can answer them in the chat.
Hi, thank you. That was an awesome talk. I love that. It was great having you on, and keep submitting talks. We'll love to have you on again in the future. Awesome. Thank you.
Thanks, Karthik.
Bye bye. Awesome. So next up, we have Martin on cloud workflows. So let me just add you to the stream. Awesome. How are you doing?
Hello. I'm doing great, thank you.
Awesome. We love to see it. Well, I'll let you go straight into your talk, and we can have lunch after. Brilliant. Cool. So I'll add your slide to the screen.
Nice. Good. Hello. I'm here to give you an awesome talk about what's new in serverless orchestration automation, about cloud workflows. So let's see what we are going to cover this in this short session as well. So about me, I'm a Romanian, but actually Hungarian living in Romania. I'm a GDE on cloud. I answer a lot of questions on Stack Overflow where I built a huge profile for. And you can find slides, articles on SlideShare or on Medium. I deactivated the paywall, so you should be able to access it. You can connect with me on Twitter under Marston Kodok as well. But today's agenda is about cloud workflows. We will see what is it, cloud workflows, practical use cases, and I have brought you 6 new additions, like what's new in workflows. And I will have live demo. Hopefully it will go nicely as well. So cloud workflows in the Google Cloud portfolio. I heard that today you had another session, so I won't cover too many new things on the workflow here, but what you need to understand is that workflow sits on top of all the services, all the cloud and external to cloud services, which are accessible by a HTTP call, either GET, POST, PATCH, whatever HTTP call is. Essentially, if you want to classify it, it's not a VM, it's not an API, but it's an engine that orchestrates and integrates all these services together. So either you could automate the cloud, or you could connect APIs, Google APIs, without worrying about authentication and so on, because those are built in, or connect external APIs. And here you have some basic examples, like could be Bitly shortener or SendGrid or a trademark service, whatever you need to connect, which is accessible by HTTP and an API key, whatever. And also other clouds as well, because everything which is callable in a HTTP environment, it's part of the workflow and can be set up as a step. Essentially, step automation as an engine is what is cloud workflow. So you need to understand that is having a chain of steps, either in a workflow environment or sequential or some parallelism with it. It's not fully parallelizable. Some parallelization is possible. It has a declarative workflow language, which I really love, YAML. Per se, I love it because we don't need to maintain any library, any version like Node version or Java version of it. I set it once and it's there for 8 to 10 years, so it's very nice. It's a managed service, part of the GCP platform. It has a decent pricing. I would say that internal steps and external steps are in the different categories. And of course, you can have a bunch of executions and built-in decisions added into the logic of your workflow as well. And it integrates with any Google Cloud product without worrying about authentication. This means that the callable service account who starts the workflow, if it has permission to do the other actions on the Google Cloud, it will automatically work well in the GCP environment. And I will jump straight to the code examples because people want to see a lot of examples for it. Essentially, the basics, I need to explain the basics. So essentially, there are steps, there are HTTP calls. Let's say that GET and POST people use it frequently. I used PATCH as well. And sequencing 2 steps, but it can be multiple steps as well. There are some workflows which look like a function or let's say even a library, but these sub workflows help you to reuse code or actually get recipes from the internet, copy paste the sub workflow examples. and connect anything on cloud or on external service. So I will jump now into my VS Code, and let's see here what we have right now. So what you see here is that a workflow which is using the Bitly API, and it has an API key inline here. That's not something you need to do. I will show you how this works differently. And now you have a definition of it. If you want to deploy it, you need to run either API or from the screen, but here in the code we are going to use the gcloud utility. As I'm in the VS Code, I've set up here tasks that I'm able to actually deploy individual workflows. So when I click a deploy, it executes gcloud workflow deploy, the name of the workflow, and the source file for it. The source file could be something that you deploy as well. So again, gcloud workflows deploy and the source file. I put it here nicely using this tasks JSON file definitions for each action, because this way I am able to actually quickly by a click access all these operations. So as you've seen, the deploy was almost instant. Now I need to execute it again. Gcloud execute, and the workflow name is the command that's being called. And this returns a command which describes the execution ID, because each execution gets an execution ID. When you are a developer and in a debugging process, there is a command describe last, and if you have gcloud executions describe last, it actually lets you to describe the last executed call. And this is very handy when you deploy and test and in a developer environment for this. So what you see here is that the GCP workflow has executed, and the output is this one, which is the long URL shortened to, where is the link here? Here is the link shortened with the Bitly service. It's straightforward, only a couple of lines of code, and that's a basic example of a workflow. What you see here is that essentially there are two steps here. One is the shorten and one is the return. Then you have the call statement where you have here the algorithm that can be either a connector or a HTTP call. You have the parameters for it, and the result is a JSON object where you are able to access parts of it, like a body as well, or I could get to the body link if I want to get only the link of it. Now this is the basic one, and now you may ask on which project did it run. So in the status bar you see here that the current project is marked on data. In this status bar the snippet is actually a GCP project switcher extension, which I am the author, so I'm featuring for you. So go ahead and install it in your VS Code as a tool that helps you to see the status bar and to switch quickly the projects as well. Now, let's go back to the slides and let's see what's new in cloud workflows. So essentially, string functions, JSON, or iterating syntax, map, and dynamic kicks are a constant addition. So they are new and new functions added to this group of language processing and so on. I really like the string functions and also iterating syntax as well, in order to process multiple things in the workflow engine. The JSON strings are a couple here on the screen, but I just wanted to reference only a few. This is very handful because you are able to actually obtain a string, then you can actually split it, make an object it, or get a part of it and use that in the next step of your automation in order to quickly connect services. Next, in the What's New workflow series is that resources have been increased to 256. Why it's important? Because you are actually in a YAML language. This is per se in a function, a workflow, but the limits were low, and now they have increased it in order to get you to process a larger API response as well. So it's very helpful that you have this limit increased. Scheduling workflows from the UI. So essentially, the basic stuff when you develop a workflow is that it needs to be triggered. And one of the triggers could be a schedule-based trigger, and that's now easy from the UI to access it. The GCP console, if you see it, and if you go to the Cloud Workflow section, when you hit Create, now here you have a new trigger, and Scheduler is one of the options that is available on the UI in order to get you going with your workflows. There will be soon adding new triggers here, and we will be able to, for example, add the event arc system as a trigger. It's coming very soon to the portfolio and so on. Now, one more thing. So connectors is a basic thing. It sounds basic, but it's extremely helpful. And why it's extremely helpful? Because they added all the connectors for most of the GCP APIs and services and products for it. Why is it good? Because connectors is a string syntax and not a HTTP syntax. So essentially, let me show you in a basic example, because people ask me to actually what are connectors. So let me minimize this here. So continuing the example of the Bitly shortener API, what you have here now is that we have a secret, and then we decode the secret and so on. So essentially, I put the API key in the Google Secret Manager, and I use the connector, and the connector here, you see that I'm using a dot notation, like Google API Secret Manager version 1 projects. This is in the manual, but I'm not using a HTTP syntax. The Secret Manager, it has a HTTP syntax, it has an API. You can use that too as well, but that's a longer way to actually use with the connector as well. So essentially you have it here. The advantage is that it will automatically have the built-in authentication. I don't have any code to actually deal with authentication here on the GCP part. And it automatically decodes the secret. So there are services, for example, Secret Manager automatically returns by base 64, but when using the connector, you have the decoded secret, and then you can use it in the next step, basically. So connectors are a shortener syntax to GCP services, and it helps you to develop much more quicker using these syntaxes. So essentially, I'm showing you that this is the longer syntax. For example, if you want to use the HTTP call in order to create the URL to the Secret Manager, to add the authentication layer and so on. But after using connectors, you get only a few lines of code by using the dot notation of the connector. Essentially, connectors have also built-in retries. It has a timeout that can be increased to 1 year, so it's really helpful to actually run really long operations. And it has also syntaxes to set up the backup parameters and of course the retries and ability to define custom retry policies. I've never done those, but I've seen services where you can actually slow down based on the retries. This is a table, just a basic of what product is available as a connector. This is a growing table, so this is not the, let's say, the last up-to-date solution, which products are handled by the connectors as well. And now callback as a feature to the cloud workflow. It's a new addition. It has been launched GA only last week, so it's very fresh. Callback endpoints lets you to write async executions. or human in the loop, which means that you can pause the workflow, wait for a human to take action on some other system, to take action on a screen, and when they had hit the action, that service pings the workflow in order to resume it. And it's very helpful, this callback system, because it resolves a lot of pain points of developers like polling or managing tables, state, and so on. So essentially, it's a webhook endpoint where you signal that an external event has occurred. And it has two syntax segments. So essentially, you need to add in your code a create callback step, where you have this connector using events create callback endpoint as a name. You have here the method if you want to have a get or a post connector created as a callback. And then somewhere else, so here the code will pause until the next step will actually be called sometimes in the future. And this is called await callback. This is the name of the step. Here you have await callback as the connector, as the definition of this step. You can have here the expanded JSON variables from the connector request, what they have sent you here, the callback details, and then you can have a timeout limit. What's important to understand that this timeout limit can be up to 1 year. So essentially you can pause a workflow for a year and you get the callback action somewhere, let's say, near that time window. Now, when we talk about callbacks, we need to somehow understand what can be paused and how is the anatomy of a cloud workflow. Essentially, when the workflow is triggered, it's in a running state, and it executes step 1, step 2, step 3, and so on, and succeeds. Now, there could be also failures as well, like it could happen an exception and goes into the fail state, or actually one of the steps naturally can time out and go into the fail state. So this is actually something basic, but then there is maybe one step is a callback await step, where it means that it creates an endpoint, like a callback endpoint, and it listens on that endpoint. And naturally, we can infer that an external event shall happen in order for our workflow to actually resume it. So an external event happens, it accesses the endpoint, the callback. It's referred to as an incoming call. The incoming call will continue the workflow. You can have here additional parameters feed it into the workflow. Essentially, if this is not happening, then it will time out and the workflow will fail. Why is it important to understand all this? Because callback details lets you to actually analyze business logic in a much modern way, and often you don't need to actually sleep for an operation, like sleep 10 minutes. You can engineer your solution to actually get the callback, or you don't need to actually have tracking tables, because you can feed out parameters to the external call and it will actually push back the variables for that. And you don't need to track where your workflow has paused, because all the variables will be accessible by the state engine of the workflow. And it replaces polling, so you don't need to actually do regular calls. You can engineer your solution with the callback and you get one single request and not a polling operation. I've got a question that the webhook endpoint is open to the public or not. Well, it's secured with authentication, so only who has access, it will be able to actually ping the connector and ping the endpoint, the webhook endpoint, where they signal it that the workflow should resume. It's event-based, and you have access to the full callback details, so the callback request actually holds additional arguments to it, headers, query, body, raw, and it's available also in the JSON format as well. So quickly you are able to read out either from headers or additional parameters part of the query and so on. So why is it important that this is so handful is that a connector could be something that it's an external API, and you set up there a webhook, and the external API, it may send you a parameter either in the query level or in the headers level, and then you are able to read out from inside your connector, and that's really helpful. Now, and finally, let's talk about what's coming next. So EventArc integration will come very soon. Hopefully they will launch it in a public way in a few weeks. Right now it's in private preview. You can get access to it. And what this means? It means that you are able to trigger workflow using the EventArc system. What is EventArc? EventArc is a system which loosely couples services that react to state changes, and it's part of the GCP platform. Essentially, it's an observer engine, and whatever it's in the logs, and could be anything in the logs, EventArc can pick it up and signal it, and then you can take action on it. This will eventually let you to connect all the fancy stuff of the GCP platform with all the elements of it. And not just only GCP, because anything which is logged as a custom sources, for example, you publish to the PubSub, is being able to pick up by the events and the EventArc system. And it will be able to, for example, to feed you either to Cloud Run or to Cloud Workflows. To feed to Cloud Run, it's happening as of speaking. The Cloud Workflow, it's in preview and soon will be launched in a GA way. This will open up to actually anything on the internet, anything on the cloud to actually connect with as an event source, and it's an extremely powerful solution in the orchestration and automation engine. Let's see how we can go and do some advanced stuff in the orchestration engine. So let's dive into some of the examples I have built out. So what we have here is that you can use workflows to issue Firestore backups. Why it's important to have this? Because Firestore could have a backup automatically, managed backup, but you need to, for example, restore it. And you need to issue a manual backup. And the manual backup is a button on the interface. It has an API call also, which means that it qualifies for automation. You could have a cloud scheduler to trigger a workflow where you set up a service account key, which has access to the Cloud Firestore and has access to the cloud storage systems. The cloud workflow will eventually create an API call, which will trigger the Cloud Firestore backup, and it will put on the cloud storage. It's extremely simple workflow. It will trigger based on the scheduler. The full tutorial is available on my Medium wall. Another example, a bit much more complex, is to actually use workflow to load cloud storage files into BigQuery. So here comes into action that the cloud workflow, when it starts, it will look, for example, in a cloud storage bucket, a list of files. For each file, then it can either extract segments from the URI and use as table name, or use as, let's say, additional partitioning and clustering operator in BigQuery, but it lets you to automate all that for all the files, and the files are automatically in BigQuery. This system is extremely helpful if you have placed some file onto cloud storage as well. And one of the much complex example is how do you run shell commands on a compute engine VMs in a serverless way. And by serverless way, I mentioned that the VM could be stopped and you need to wake up the VM to run an arbitrary command and eventually shut down the VM. This means that anything who doesn't qualify, for example, for a serverless engine or for a Cloud Run instance, you could place into the VM, And arbitrarily, you can start the VM only for the operation, run the operation, and stop the VM when the operation signal. It could be something like a database backup or some large GPU operation or some large disk operation, which are not frequently possible on the serverless environments. For example, we usually do backups which run for 3-4 hours. It's really complicated to actually do that. Or there are transformations on the files which run more than 1 hour, so it's not suitable for serverless jobs and so on. So that's why there is the Compute Engine VM, and you can create anything. The article essentially describes that a workflow which has permission also to run all these services and has permission to the IAP, which is the identity-aware proxy, will start the VM, essentially calling the Compute Engine API, will wait until the VM is up, then it will submit a Cloud Build job. Why it needs to submit a Cloud Build job? The Cloud Build job essentially can have a syntax of a shell command. And this is the tricky part. This works only on Linux. So essentially the Cloud Build job will have a part of the shell command that you need to run. And the Cloud Build can connect to the identity-aware proxy to your Compute Engine VM, and the shell command is executed on the Compute Engine VM. Cloud Build is just the connector using the identity-aware proxy. Once this is finished, we can stop the VM, for example. Also, this article is available on the Medium engine as well. Let's jump to conclusions. So it's extremely developer friendly. It's easy to build and operate. It scales out. So essentially it's fully scales to thousands of executions. It doesn't lose state. So essentially you need to understand that even if you pause or have a callback waiting for months, the previous variable will be there when the callback happens and the workflow resumes. It handles automatic errors as timeouts, out-of-the-box supports of cloud APIs. It's auditable. Most of my managers want an orchestration service where they are able to see which action, when, by who was taken, and workflow is auditable. It's a perfect fit for this. And it enables you async workflows. So essentially, the Word lets you to build out anything, even human in the loop, where they wait where the workflow waits until a person takes an action and resumes later. So the possibilities are endless, from marketing, retail, down to the developer road as well. You can automate the cloud as we have demoed. You can have shell script replacement, as I've shown you that you will find an article which I created a tutorial how to run in an orchestrator where a Linux shell command. You can orchestrate DevOps workflows, you can do conditioners, you can do callbacks, and so on. For the retail, you can have data gathering and processing, for example, or in the marketing system, you can have, for example, workflow-based emails, discount promotions. These are nicely fit into this workflow engine. You just need to generate the respective step, the synchronizing with your system, and then you start the workflow, and it means that it will trigger based on the schedule that you set, for example, for the workflow-based emails. Now, this concludes my talk today. Slides are available on SlideShare. Articles about cloud workflow are available here on martonkodok.medium.com. And if you have any questions, ping me on Twitter, or I will monitor the streaming chat as well, and I'm happy to answer it there as well. Thank you for having me here. Have a nice day, and keep going forward with your nice conference.
Awesome. Thank you, Martin. It was great having you on here.
Thank you.
Thank you. Cool. So it's just about lunchtime, so we will be back at 2 p.m. and I look forward to seeing you then. See you then. Hello, hello, hello. I'm not muted this time, so we're back. And we've got a free talk without a break. So first up, we have build a serverless COVID-19 REST and GraphQL API from Maxime Bugnet. I have pronounced that very wrong, but I hope you'll forgive me. So let's just jump straight into it. Hi Maxime, how are you doing?
Hi, how are you? Thank you very much. I'm trying to finish set up the mic. Hope it's not in the way.
Doing
How is the sound? Is the sound good?
Yeah, not bad.
Okay,
Awesome.
perfect.
So
Hi,
I will
everybody.
let you get straight into your talk.
Thank you very much.
Cool. Awesome.
Hey, everybody. So I'm Maxime Beugnet. That's the right pronunciation this time. And today I'm going to present to you 25 minutes to build a serverless COVID-19 REST and GraphQL API. I'm a senior advocate based in Paris for MongoDB. So that's also the tech I'm going to use to present to you this talk right now. So let's jump right in. So I think everybody knows that if I'm at home today, that's because of COVID. So that was the word before, and that's basically the word now. So the idea that I had at the very beginning of the pandemic was to basically make the data available through charts and APIs for everybody, right? So everybody could benefit, from the data, and we could all use them to eventually make the situation a bit better. So as you can see right now, I built, for example, those charts using MongoDB charts. You have the link in the last slide, and also on my Twitter account, I shared all those links, so you can access all that data. So that's, for example, built with MongoDB charts. And what I want to show you is how I built that and where I got the data from and the journey kind of that I went through, to get all that together. And then I want to build the REST and GraphQL API, which are also actually the real versions of those two GraphQL and REST APIs are also available online for free. So you can use them to build absolutely whatever you want. So let's jump right in. So of course, those charts here were inspired by John Hopkins University, and those charts, they provided like back at the beginning of the pandemic, like 2 years ago now. And so I wanted to basically reproduce more or less at the beginning what they produced right here. So luckily for me, in the term of use at the bottom, they provide actually a GitHub repository that you can see right here with this small arrow. And this GitHub repository looks like this, right? So it's on GitHub, it's like a few folders and some CSV files. So I didn't want to do something better than what they were doing, right? So because they actually used like tons of data sources to fetch all the data and try to pull it together and consolidate, etc., clean, etc. So at first I thought I could do better, but then I looked at the list and I was like, all right, so no, I'm just going to use that. So the data that I provide is as good as, it is, right? I can't be any better. That's all the work they do for me ahead of the line. So I can't do any better than that. So they produce a few folders, actually two big folders, two main folders. One is called daily reports, which is something like this. So it's basically a list of CSV files, one per day. So it was looking good for me, right? Because I wanted to increment my data every day with the new data. So at first it looked like a good idea. So let's look at the very first file in that list. It looks like something like this. So it's a basic CSV file, right? So you have province/state, country/region, last update with a date with a weird format. And then you have confirmed deaths and recovered cases. And you can see that some values are missing because we can assume it's zeros. And that's what you get, right? If we look now at another random one in April 2020, that's a lot different, right? You see that everything is different. We can play the game of the 7 differences, but there are a lot, right? So we have new columns like FIPS and admin2, which looks like a city. We have province_state, which is not slash anymore. It's now an underscore, which is different. So it's annoying to parse and to make a parser and integrate that with your data set, etc. If we change the name of the fields every day, that's going to be a mess. We have also latitude and longitude that just came in, and we have long underscore, which is a weird underscore that just here, just to be annoying. And also now, like, for example, confirm, death, and recover, now we have zeros instead of a null value, right? So again, that's another difference. We have some new colons at the end, etc., etc. I think you get the idea, right? So that's not consistent. That's not predictable. Looks like the data can change and the format of it can change every day. So I can't really work with this, right? I need something more consistent, more predictable, especially if I want to build APIs on top of that. So not good. So if you want to build a good API, the key to success for this is consistency, right? You want your users to find the same patterns, every day, the same type of data, try to respect the schema as much as possible. So that was no good for me. So there is another folder, luckily, which is called time series folder. And in this folder, there are only 5 files that you can see right here. 3 files are called global, so they concern basically the countries, or the countries eventually divided in states, like for the big countries like the US or Canada, France, etc. And there are 2 other files, which is confirm US and death US, which is just for the United States, where all the data is actually subdivided up to the counties. So that's 3 level down in the divisions. So it's very precise, and that's how you get the small points, on all the US map, right? Because you have all the details, right, of the US. So the files look something like this. Confirm the global, for example, on this one. So this is the data that you get, and basically you see the pattern here. So of course the files goes all the way to the right, and every day they add a new column, on the right of that file, right? So it's pretty simple, because the CSV file is the same every day, and the format is the same every day. They just add an extra column at the end every day. So that's something I can work with. I have a consistent schema here, so it's way easier to work with that type of data. So for death and recovered cases, I had exactly the same file. So I just needed to assemble them so I could make like 1 document per day per place, for example. That's ultimately the goal that I wanted. Have 1 place, 1 date, and the values, for that particular day, right? Which would land in the end into 1 point, in my graphs. So if I use out of the box that schema and import it with Mongo import, which is the default tool to import CSV files into MongoDB, I end up with an absolutely terrible schema, and I can't use that to produce my graphs and my APIs, etc. I would end up with something like this, which is basically the raw CSV completely flat. And that's definitely not what I want, right? Here it's 1 place, but like all the data for all the days, the days are actually here keys and not values, which is very not practical because I can't run a query easily on the fields like this. So that's really not what I want. Instead, I want to work with a date like this, which is an is a date. And the date here is actually a value, which I can query on. And the localization, for example, it's an object called a GeoJSON object, which is way easier for me as well to work with in MongoDB charts, for example. So this is a lot better. So I needed to reshape my document, right? So I didn't use Mongo import out of the box. Also, there is a lookup table, which is an extra file that's provided 1 level above. And here they provide like an extra informations like ISO code. They provide the population. They provide a few extra informations. And I also wanted to kind of blend in the data together with this table. So I had like a lot of information for every single point I had on my chart, and run more statistics, etc., etc. So I applied some Python magic. The script is actually available online if you want. It's on the GitHub repository. You have the link as well at the end of this presentation, and it's also on my Twitter account. So the final documents that I had finally was something like this, right? So you can see that it's a lot cleaner. It's a lot smaller as well, because now I have only 1 like set of values, so confirmed, death, recovered per day per country, or per place, basically per place in the map, which can be either a country entirely or a state or eventually a county for the US. But it looks something like this. And as you can see, I have at the top the information about the place I'm looking at right now. So right now it's France, for example, mainland, I think. And you have a date, which is an ISO date, which is easy to query on. And then you have confirmed death recovered, and also calculated field, which is confirmed daily, death daily, and recovered daily based on the previous day, right? So those fields are actually calculated by me using the aggregation framework on MongoDB based on the cumulative value you have for confirmed death and recovered in the file. So basically I do for every day, I do today minus yesterday equal value of today, right? It's as simple as that. But using the aggregation pipeline of MongoDB, which is building this automatically for me, it's not that trivial, but in the end, it's super efficient. So I end up in the end with a few collections, actually 5 collections, as you can see at the bottom. This is a view from MongoDB Compass, which is a tool you can use to log in and visualize your databases and collections, etc. So here you can see a few collections, which is basically different, blend of the different files you saw. The US only use 2 files, from the US, and you have like more than 2 million document now, like actually way more because this is a bit dated. Maybe it's about 3 millions now. You have one made-up collection of metadata, which is just recreating the metadata for those countries. For example, you have the list of countries, you have the first date, the last date, you have the list of counties, the list of states, etc., etc. So you can use those metadata to query the REST API and the GraphQL API, for example. And then you have a few collections like global and US, which is basically global is just the view of the countries and states, and global and US, it's basically global plus the US only collection blended together to produce this big collection, which is the main one really, which is the one in which you have the most details, etc. So all my charts, for example, are based on that collection. And you have country summary, which is an extra collection that's built with MongoDB as well, using the aggregation pipeline, where I aggregate everything and I want just one single point for one single country. So you have just 1 point per day per country, basically, in that collection, which is a bit of a summary, right? So let's hack now, and let's do GraphQL and REST API demos, and I will show you in MongoDB Realm how to build that. So first of all, I use actually MongoDB Atlas, right, to build and host those collections online. So it looks something like this. Let me do in a bit. Yes, looks good. So here you have like my 2 clusters that I'm using, which is pre-prod and the actual cluster that's currently in production. You can actually access this one. I have a free open access to this cluster, so you can also query directly the cluster if you want with a read-only user, of course. And in this collection here, so that's MongoDB Atlas, where you host your MongoDB clusters. And in here, you have also at the top Realm and charts. So Realm, which I'm going to use right now, it's basically a serverless GraphQL, a serverless backend system that comes on top of MongoDB Atlas, and in which you can build like REST API, GraphQL APIs. You can build authentication system. You can host a website as well for your front end. You can use sync as well, which is to synchronize the data across different devices, for example, mobile devices or web apps, for example. So it's a very fully featured serverless platform on top of MongoDB Atlas. So let me show you how it looks like. So when you click on Realm, you land in here. So that's the production app that I'm using, and we are going to rebuild right now a small piece of it. So let's try to create a new app, which I'm going to call DevFest, for example. I'm going to connect to the COVID-19 cluster, which is the main one in production. And I'm going to make sure that my app is deployed locally in Ireland, because the cluster is right now deployed as well in Ireland. So if I stick the two together at the same place, of course, I get better latency and better performances, basically. Let's start with, for example, the REST API, right? So the REST API, it's changed actually recently. We moved on from third-party services to something that we call now HTTP endpoints, which is right here. So that's what I'm going to create right now. That's why you see those warnings here, because it was changed recently. So you can add an endpoint here. And let's say that I'm going to call this root/global, for example, and query the global collection. I'm going to say it is the get, right? A get call. And then I'm going to say that, yes, I want to answer with results. I'm going to skip the authentication part, and I want to link a function to that webhook, right? So I'm going to call this function global, for example. And as you can see, there is a sample of code here. So of course, you get basically in the input of that function the query, the headers, and the body, which you can use to build and do the query, do the aggregation, the whatever query you want on the MongoDB cluster, and then you have a response which you can use to build your response. So right now, I just want to make it super simple, just to show you how it works. And with just actually that one line here, it's already enough to build a REST API. So here, if I just do return with the context service.get MongoDB Atlas, which is a direct access to my MongoDB Atlas collection, I can access the database here, which is called COVID-19. And then here you have the name of the collection, which is global for me. And I can just run a find one and return that, right? So I'm just going to find a random document in here. So as you can see, with just like 3 lines of code, I can just save this at the bottom, right? Okay, so now it tells me that I have to review the draft and deploy, which I'm going to do right now. So I'm going to deploy the whole app. Okay, that's done. And now I can use this curl command right here. And I should be able to query. So as you can see, it says no authentication method were specified. That's because by default, all the functions needs to be authenticated, right? They need to be executed by a user, right? But in here, I want to do an anonymous REST API. So I need to go back in the functions. I need to go to my function here and in the settings. And as you can see here, it's linked to the application authentication, but there isn't right now. So I'm just going to check the system here. So it's going to be executed by the system, which basically bypass the authentication system. I'm going to save the draft, review and deploy again. And if I re-execute the same thing, as you can see, now I have my value, right? So I have the first value actually of that collection, which is for Afghanistan, apparently, with a population of, some number and for some date, etc., etc. So as you can see, my REST API is already deployed and it works, right? So it's public and everybody can use it. So of course, this is a bit the simple version, the super simple version of a REST API. The real one that I have online actually looks like this. So you have the function, you have here I'm retrieving the fields that you can pass, as query parameters. Same line that you saw, I access the collection right here. I build a query, a projection, and a sort. Here I'm checking the fields, I'm checking all the things, you pass. So I'm checking that the country exists, or I'm checking that the country is here, it's not undefined, etc., etc. And then in the end, it just looks like this. It's a very simple, like 4 line of code. Collection.find, I pass the query and the projection, I pass the sort, transform that in an array, and then the array, I get the docs, because it's a promise, and I just do response.setBody json.stringify docs, and I get the response, right? Just like you saw, in the previous example. So as you can see, this is super simple to do, and in like 4 line of code, you can do like a fully fledged REST API. So that's great. So now let me show you how to do a GraphQL API. So back to my DevFest application in MongoDB realm. Let's check how to do a GraphQL API. So the first thing it tells me to do is to generate a JSON schema, right? Because GraphQL relies on schemas. So here I'm driven to the rules stuff in the app. And here I can select, let's say, global, for example. And I'm going to say that I can select a template, which is, user can read their own data, or user can read and write everything, etc., etc. So here it's user can only read all data, because I want to make it like a public GraphQL API. I'm going to configure this collection. Here I'm going to click on schema, and I'm going to generate a schema just for the global collection, and I'm going to sample like 500 documents. It gets me a schema that looks like this, right? Based on the fields it found in those 500 documents, and I see that it's missing state here. I've noticed it's missing state, so I'm just going to add it here, because some documents don't have state, so it's easy to miss, for the algorithm. I could choose to sample more documents as well. It would take a bit more time, but you would probably find it at some point. I'm going to save. All good. And now if I go back to GraphQL, I have a different view. As you can see, I have my endpoint here at the top, and I have here GraphQL with a query, and I can already execute the query, right? So again, we get the Afghanistan very first document in the list. If I add an S here, if I make it pro, here, I get now a list of values. So that's the first 100 documents now in the list. And you get also the documentation here on the right, which confirms that you have now 2 endpoints like global and globals with a default limit of 100. You can sort by, you can run queries, etc., etc. So our GraphQL API is now available online. I can review and deploy, but before I do that, we can read here that all the GraphQL queries needs to be authenticated, just like actually the REST API, it's the same problem. So I'm gonna create here an authentication system to allow my users to connect. So as you can see, I could, go all in the security, like using Google authentication or my even own custom GWT authentication, whatever email password, it's really up to me. But because I don't have like 12 hours to do that, I'm just gonna go with the anonymous authentication and activate that. So now I'm gonna redeploy again the app, click on deploy, and now I can switch to my demo. So here I can use, so first actually I need a few things. Here I need to collect the DevFest app ID, right? So I need to collect the unique app ID of my collection, of my app, sorry. And I can copy paste it like here. Looks like this, right? It's a DevFest dash and a small code. So to create an authenticated anonymous user, I'm just gonna connect, just gonna use like this line right here, this query. I can send it right here. And as you can see, I retrieve an access token, a refresh token, a user ID, and a device ID, right? So what I want here is the access token. I can retrieve that. Now I'm authenticated. And in this query here, I prepared already a query like this. So where I'm sending a GraphQL query for France, where the state does not exist. So that's basically the mainland in the database. And with a date greater than this and less than that, and I sort by the date, and I only retrieve the date and the confirmed daily cases, right? So the query is actually built right in this query here at the top. And I just need to copy paste the token right here. And I can send that query. And if everything goes right. Oh, I forgot the app ID here. My bad. Always forget something. I love demos. Up. Right. So as you can see, do that again, right? So I get my 3 data because I restricted on the date, and I get the confirmed daily cases for France, mainland, for like those 3 dates I asked. So yeah, that's it. It basically works. I could also do the same thing with email, password, authentication, etc. It's super easy to do. You just need to activate and run the query, basically. I already explained that. I think you get the ID. You can use any authentication system from that list, to use GraphQL APIs, of course. So yeah, that's it for me. Thank you very much for your attention. I hope you have a great rest of the day and enjoy the rest of the conference. You have all the links that I promise you in here. So you have access to MongoDB Atlas. You can create a free account today and try the service for free, because we have a free tier with the M0 cluster, which you can use for free to discover and play. Everything I built actually in here is probably enough to build this service. And you have access to the 3 blog posts I provided already to access that data from John Hopkins, transform it, and you have the demo of the REST API and the GraphQL API. You also have access to the MongoDB charts dashboard that I created. And of course, if you have any questions, you can reach out on Twitter. You have my Twitter at the top. And you also have the community MongoDB forum, which is available to ask all your MongoDB related questions, and where I am available to answer. Thank you very much.
Awesome. Thank you, Maxime. That was a brilliant talk.
Thank you very much. I'm glad you
Great
liked
having
it.
you.
Are there any questions, maybe, or do we have time for questions?
I don't believe so, unfortunately. I do have one question before you go. Do you think graphical will replace the normal SQL or NoSQL like request formats, if you get me?
Oh, that's a good question. I don't know. It's hard to say, but I feel like people are very, very used, to SQL and query, like the MongoDB query language, also that we now call the MongoDB API, I think. Yeah, I'm not sure. I'm not sure GraphQL is going to replace something. I'm not even sure it's going to replace REST, to be honest, because that's also an extra layer of complexity and a different way to shape and interact with the data. So I don't know. Future will tell us.
Absolutely. Love it. Awesome. Thank you, Maxime.
Well, thank you very much for having me, and hopefully see you next time. See you around.
Yep. See you next time.
Thank you. Bye-bye.
Awesome. Thank you. So next up, we have security and serverless compute on Google Cloud. Take over the control of infrastructure by Guilherme. I believe I've said that correct.
Yeah, it's Guillaume.
Guillaume.
As
Okay,
yeah.
thank you.
No worries.
Brilliant. Well, I'll let you jump straight into the talk. I'll show you screen now. Awesome. Take it away.
Yes, I will share my screen. Okay. Yeah. Okay. Yes. Can you share my screen, please?
Yeah, it's. Oh, I'm sharing the wrong screen. Sorry.
Yeah.
That's my bad.
Perfect. Thank you very much. So, thank you everyone to be here. I'm Guillaume Blaquier. I'm Google Developer Expert on Google Cloud, and I'm also Cloud Architect at Accenture today. And I would like to talk to you about serverless and security, because it's a too trendy topic today. But before going in the detail of serverless and security, I just would like to focus and redefine what is the serverless. Serverless, in fact, is an operational model. That means you have nothing to manage. You don't manage the servers, the network, the security access with the firewall rules, and all these things. What you focus and you spend your effort is on your services, microservices, because it's also the trend. And you have to develop, to deploy, and to create your services on top of a layer managed by the cloud provider that you have to trust, but not by yourselves. And when you build your services, you must create stateless services. That means you don't store the data inside your service. You need to store the data outside, in database, in blob storage. There is a lot of service on cloud to store your data, but not inside the service itself. Why? Because in serverless, you can scale up very quickly and scale down to zero, because you will pay as you use the service. And for that, you don't have to have a disk to attach to data, to backup, to save, and so on. It's too slow, and there is too much constraint to do that. That's why the services are stateless. In this context, as you understand, you focus only on your code and never on the infrastructure and all the management. And when we talk about serverless, there's a lot of products, especially on Google Cloud. And this talk is especially on serverless compute. What serverless compute is the product that can run the code that you write. That means on a cloud function, you have a function, a small piece of code, and you can deploy your function and run your code. You have App Engine. This time it's not a function, it's a web server. You deploy your code with your web server, with Flask, for example, in Python, and you deploy it on App Engine. And the last one is Cloud Run. It's like App Engine, but it's a web server, but you package your web server inside a container, and you deploy the container. And so you have the responsibility and the capacity to customize this container with the base image, with system libraries, system dependencies, in addition of your code that you deploy. You have much more configuration and possibilities with Cloud Run. Now, it was for serverless. Now, why the question about security? The question comes from the new paradigm, because you don't manage the network, you don't manage the VMs and the OS, the patch, and so on. And the security teams in your company can have these kind of questions, and it's legit from them, because they want to ensure the same level of security in the new world, in the serverless, in the cloud, than they had existing in their on-prem or in their legacy infrastructure. The legacy policies, most of the time, is about the network. I would like to have a static IPs when I go to the internet. I would like to hide my service from the public internet, because it's only internal and no public exposure is required. I would like to ensure the encryption of the data in transit, and to add my custom domain on my services. Of course, for business continuity, to have a high availability of the service that you deploy, to control the access to the service and the permission that the service has to access to other cloud components. And finally, to protect your services from external threats like DDoS attacks or code injection and so on. Last point is about software supply chain, because it's one of the major issue recently that we have, and we would like to secure this part. So for that, you need to use serverless product, but also to take over the control of the infrastructure that you don't manage. And sometimes it could be difficult because it's not your infrastructure, it's the infrastructure of the cloud provider. But it's not impossible. So the first topic, for me, it's the most funny, it's about the patch management. How do you patch your servers? Of course, you don't manage the servers and you don't have to patch them. That's why serverless is very efficient, because you don't have to spend time and money to patch your servers. But that don't mean that you have nothing to do. In fact, when you deploy your code on your services for Cloud Function or App Engine, you deploy your code and you have some dependencies. And you can have security issues in your code or in the dependencies, and you need to patch your code and the dependencies to be sure that you keep the highest level of security in your application. And when you talk about Cloud Run, it's more than that, because you bring your code, your dependencies, but you package this code in a container. And in a container, as I said before, you can choose your base image, you can choose the system dependencies, the system libraries that you want to add inside the container in addition to your code and your dependencies. That's why you have a lot of things that can have security issues, and you need to fix those issues. And a good practice for that is, for example, to rebuild every week your application with your CI/CD to play your unit test, your integration test, and if it's okay with the latest version of all the dependencies and the latest version of the system libraries, you can redeploy your code with the latest version, normally with the latest fix of the dependencies. Next topic is about the internal access. In fact, you can deploy some services inside your project in Google Cloud, inside your VPC. You can have Compute Engine, Kubernetes Engine, or other services like Memory Store or File Store that are attached to your VPC. And how to connect a world, network world, the serverless world that you don't manage with your VPC. Same thing if you have an external platform with your on-prem environment and you have a connection with a VPN or one interconnect, how to use this private link inside your VPC to access your external platform with the serverless product. For that, there is a tool, a feature very, very important and very interesting in the serverless world named Serverless VPC Connector. In fact, it's a bridge between the serverless world and your VPC that allows to route the traffic from serverless world to your VPC and then to access your resources inside your VPC, your Compute Engine, your Kubernetes cluster, and so on. And if you have an external platform, you can route the traffic to the VPN or to the interconnect to access to the external platform by private IP. And like that, you never go to the internet, you never expose a public IP to access your on-prem. You can do that with private connection. Another use case is if you want to have a static IP when you call an external service or platform. I had this use case in my previous company. We had a FTP server where we trusted the user, the password, and the requester IP. And for that, you need to be sure that the IP, you need to whitelist, in fact, the IP that call you. When you use a serverless product, it's managed by Google. It's in the serverless world. It's not your network, your VM. And when you go to the internet, you use one Google IP. It could be yours. It could be reused by another one. And that's why you can trust it because it's not your IP. It's a Google IP that can be used by any user, customers of Google Cloud. The solution here, again, is to use serverless VPC connector to route the traffic from the serverless world to, this time, Cloud NAT. And on Cloud NAT, you can attach one IP that you reserved and you pay to go to the internet. And you can reserve one or several IPs to the Cloud NAT, and thus you can trust those IPs because it's your IPs reserved only for you, paid by you, and like that you can trust them. The next question of the security team is, okay, my services are exposed to the internet, no problem, because it's a public service, it's normal, but I want to have TLS certificate to encrypt the data and the communication. And for that, it's natively proposed by the serverless product, and you have nothing to do. And you use this wildcard certificate when you deploy your services on Cloud Function, App Engine, and Cloud Run. Out of the box, it works. Now, it is the opposite. You don't want to have a public service. You don't want to let the service accessible to the internet because it's an internal service, because you have internal process, batch processes, you process critical data, and you want to reduce the surface attack, the attack surface, because it's not a public service. No need to expose them publicly. No need to take some risk to expose the service publicly if it's only for internal jobs. And for that, we have a solution for Cloud Function and Cloud Run. Not with App Engine, we have firewall rules, but it's not exactly the same thing for App Engine. But this solution is only for Cloud Function and Cloud Run. In fact, you can say to Cloud Function and to Cloud Run, I want to restrict the ingress, the traffic that come to the serverless services. I would like to set the ingress to internal only. That means only the traffic coming from your VPC can access your serverless resources. If you want to access serverless products, for example, a serverless function from Cloud Run, that is, and the Cloud function is set with internal with ingress internal only. In fact, you have to go through your VPC. For that, you can use the serverless VPC connector again with Cloud Run to route the traffic to the Cloud function through your VPC. And because you are inside your VPC, you can access your Cloud function securely, even if the ingress is set to internal. Of course, same thing if you have some resources deployed in your VPC, like Compute Engine or Kubernetes Engine. You are inside your VPC, and so the ingress internal is obviously allowed to access your Cloud function deployed in ingress internal. Same thing if you have an external platform connected with a VPN or an interconnect, and this traffic land in your VPC. Because you are inside your VPC, you can access to your Cloud function deployed in internal only, or your Cloud Run, of course. But it's not very. But sometimes it's not what you want. You want to expose your Cloud function or your Cloud Run publicly, but you don't want a direct access to the service. You want to let the access only to a load balancer. Like that, you can set the ingress as the value ingress and cloud load balancing to allow the traffic coming from the internet, but the traffic can't reach directly the Cloud function or the Cloud Run services. You have to access before to the load balancer, and then the load balancer will route the traffic to the service, and this time the traffic and the routing is accepted. Like that, you can have a service in private mode only, with only internal traffic allowed, or to be exposed only behind a load balancer, and you can add some security layer in your load balancer. We'll see that just after, with a web application firewall, a WAF, if you want. Next topic is about the business continuity and the high availability. And if you have the habit to deploy a Cloud Function, App Engine, or Cloud Run on Google Cloud, each time you deploy your service by specifying only the region, never the zone. Why? Because when you deploy a Cloud Function, a Cloud Run, or App Engine, you deploy that not in one zone in a region, but in the whole zone of the region. And that's why, by design and natively, you are high available at regional scale. But if you want to go a step further and to be globally high available, for that you need to deploy a load balancer. A load balancer has an anycast IP. That means this IP is known in several points of the world. And behind this load balancer, you can deploy several backends. Cloud Run, for example, or Cloud Function, or App Engine. No problem. And the power of cloud load balancing is to route the traffic to the closest location to your users. If you are in Australia, you will reach the Cloud Run in Australia, for example. But also, if you choose to destroy and to disable the Australia region because you have an outage, because you have a legal reason or so on, if you are in Australia, you can continue to reach the same IP, the same service, but Cloud Load Balancer will route the traffic to the closest location available from your user. If you are in Australia, I don't know if it's in California or in Europe, the closest location of Australia, but you will be high available because if the region is not available in Australia, you will land elsewhere. Another great feature of that is if you want to deploy your services, Cloud Run or Cloud Function on all the region of Google Cloud, you can do that. It's not more expensive because you will pay only when you will use the service. And if you deploy in all the region, and for example, in Asia, you have no user in Asia, and the Cloud Run in Asia is never used, you will pay nothing because it's the pay-as-you-use service, and you are high available, and you don't pay more to have this high availability. Of course, you need a load balancer in front, but no more. A word about the permission. What the permission is when you have a service on Cloud Run, App Engine, or Cloud Function, you should have the capacity to access to other services on Google Cloud, BigQuery data, dataset, or tables, PubSub messages, topics, KMS keys, and so on. How to be sure that the service that you use is authorized to access this dataset, this topic, or these keys? How to be sure? For that, you have an identity on each service that you deploy, and by default, you use the default service account identity for Cloud Function, App Engine, and Cloud Run. The problem of the default service account is if your Cloud Function need to access to BigQuery, and if your another Cloud Function need to access to PubSub topic, you will grant the Cloud Function default service account the permission to access to BigQuery and to access to PubSub because it's the same service account for the Cloud Functions. And one function can access to a topic, and they don't have to access it because it's purpose. And same thing with BigQuery. A Cloud Function can access BigQuery, but it doesn't care. For that, you can use a default, not a default, a custom service account. In fact, you can define a service account and to add it on Cloud Function, App Engine, or Cloud Run. For each services, that means you have one service account for Cloud Function that access to BigQuery with only the permission to access to BigQuery, and another service account on other Cloud Function to access to PubSub. Like that, you have only the lowest set of permission for each Cloud Function, and you enforce the least privilege principle. And you have also a better traceability because you know which identity has access to which services, and you know which service has this service account identity. And like that, your debug and your your debug and your understanding of the service is better. Now, it was the access from the service. Now it's the access to the service from the internet. You can export your Cloud Function, Cloud Run, also with App Engine, but App Engine is not Google Frontend, it's more IIP. It's Identity Access Proxy, but it's fairly the same. In fact, in front of any Google services, and I say any Google services, not Google Cloud, that means it's the same layer for Gmail, Google Maps, YouTube, and so on. You have Google Frontend that discard a lot of bad traffic of layer 3 and layer 4, partial IPs, and so on. All of the bad traffic is discarded by this layer. And you can configure Google Frontend in two modes. The first one is public. You perform no filter. All the traffic that you receive, you forward it to Cloud Run and Cloud Function without any condition. But you can say, my service, Cloud Function and Cloud Run, is protected by IAM, Identity Access Management, and only the authorized traffic can be routed to my services. What's valid traffic or valid request? It's a request with a header, authorization header. The header must be correct. The header must be valid, not expired. And the identity in the header must be authorized to access the Cloud Function or Cloud Run. If so, Google Frontend will route the traffic to your service. If not, the request is discarded and trashed by Google Frontend. The power of that is to say, in fact, only the valid traffic is routed to your function, and you will pay only the valid traffic. All the bad traffic, unauthenticated, unauthorized, and so on, will be discarded by Google frontend and will be paid by Google, but not by you. And that means you won't pay in case of attacks if your service is protected by Google frontend with an identity. This authorization header contains a token. It's a cryptography mechanism with a short duration, and of course, it's a web standard and can be easily used by any application and services. Now it's time for the threats on the internet. As I said, you have Google frontend that protects you on layer 3 and layer 4 attacks. But if you have some HTTP attacks, you can have a problem, especially for the public services. And for that, you can add an HTTP load balancer, and you can activate a feature named Cloud Armor. And in fact, it's a customizable WAF, web application firewall, that protects you, and you have a set of rules already defined to protect you against the top 10 WASP attacks. And to protect also your money, because if you have an attack and with Cloud Armor, you pay according to the traffic that you filter, you can subscribe to Managed Protection Plus. In fact, it's a flat rate. And if you have an attack and a lot of traffic, you won't pay more and also protect your money in addition to protect your services. The final topic is about the supply chain security. And to explain you why it's important, I just would like to explain what's the threats in the supply chain security. In fact, you have a development team that develop their product and use a CI/CD, for example, Cloud Build, to build their container before deploying them. They store the container in artifact registry on Google Cloud, of course. And then they use a deployment tool. It can be Cloud Build also. It could be something else, or Cloud Deploy, for example, to deploy a container on Cloud Run or on Kubernetes Engine. So Kubernetes Engine is not serverless, it's not the topic, but the product is the same. But you can deploy on Cloud Run. That's the happy path. But sometimes an unauthorized user, a bad actor, or it could be also a member of the development team that detects a bug in production and would like to fix quickly this bug. He creates a container on his own environment, on his own computer, and want to deploy this container in production. It's not a malicious user. In fact, it could be simply a developer that would like to patch something. And he can build the container somewhere and deploy it in production. The problem of that is because the container has been deployed and has been built on an untrusted environment, you don't have security tests in your CI/CD, you don't have unit tests in your CI/CD, you don't have integration tests in your CI/CD. So you don't have a lot of rules and conditions that guarantee the quality of your container. You can deploy something with bad dependencies, with security issues, with regression error, and so on. And you can break your production. To protect that, you can use binary authorization that say, I trust only the registry for this container. That means I trust artifact registry. I can deploy that on Cloud Run or Kubernetes Engine. If the container comes from Docker, for example, docker.com, I can't trust this registry and I can't deploy this container because it's my rules in my company. And like that, only the containers that you trust, only the registries that you trust can be used to deploy the containers in production, and you protect your application like that. How it's done? In fact, when you deploy your container, you can sign your manifest and the container attestation. And binary authorization will check this attestation, this signature before the deployment. Binary authorization also check continuously the validation. In case of you choose to revoke the permission of registry, you continue to check and you can detect a container deploy from a new untrusted registry, and you can have security issues and alerts on your project. Of course, in case of emergency, SRE can use breaking glass, but with a reason, and to explain why they bypass the binary authorization feature. And you can configure your policies and attestator, of course. And you can use Cloud KMS to use a key to sign your manifest. And yes, of course, it's natively integrated to Google Cloud, especially with Cloud Build that sign automatically the manifest. Just a word, why it's not used for Cloud Function and App Engine? Because with Cloud Function and App Engine, you also use containers, but you don't deploy the containers coming from outside. You deploy your code, and the code is built by Google Cloud inside Google Cloud, and then to deploy by Google Cloud to Cloud Function or to App Engine. And that's why Google Cloud trusts Google Cloud, of course, and you don't have this feature on Cloud Function and App Engine, only with Cloud Run, because you can import container from somewhere. Just a final sentence at the end, just to tell you that if your security goes well, your business will follow, because I'm sure all of you have a company in mind with big business, promise to a big business, a big future, and a lot of great things in the future, but their future has been broken by a security issue. And personally, I have in mind, for example, Zoom. With the pandemic, Zoom was very, very popular. And at the moment, a security issue break all this dynamic. And now Zoom is not so popular because of this security issue. And it's very sad for them. The security is not more expensive if you take it into account from the beginning. It's only best practices to enforce, and be cautious with that. It's not an optional feature or a day 2 feature. It's a day 0 feature because it's very, very important for your business. So that's all for me. Thank you very much for your attention. I think we don't have time for questions, but it's not a problem. You can reach me if you want on Twitter, on Medium, or on LinkedIn, or whatever you want. And I put you some links for the products that I presented just before. Thank you very much.
Merci, Guilherme. That was very impressive. I've got to say, I would not like to tackle a technical presentation in French. Me as a native English speaker, I think you did wonderfully. That was very well done. Excellent presentation. Thank you very much, sir.
Thank you very much.
I hope you enjoyed your DevFest experience, and I hope to see you again soon. If anybody wants to contact Guilherme, I'm sure he's made his details known. Thank you, sir. So next up, we have Mario Falant. I hope I pronounced that properly. We'll get him in here and we'll see how badly I messed that up. Hey, Mario, how's things?
Hey, hi, David. Everything fine. It's actually not that bad. I mean, it's a German last name, so if you speak it as hard as possible, it's always good.
Falant.
Yeah, exactly. Yeah.
Yeah, it's a real European tour, isn't it? We're having the whole of Europe into DevFest UK and Ireland. We're so glad to have you guys here.
Yeah, sadly, I would like to join you in person, but the travel ban basically only lifted on Tuesday, so it was kind of hard to make it that last minute. But next year. But
we're looking forward to in person, man. It's all coming back. We're just going to start rocking out the presentations again. We'll have in-person meetups. It's going to be brilliant. So, correct me if I'm wrong now, Mario. A little bit about yourself. Is you're a Google developer expert in cloud and Kubernetes. You're working at a Kubernetes as a team lead, Kubernetes consultant. All correct so far?
Yes.
You've done some interesting talks around cloud, DevOps, Kubernetes, open source, and Google Cloud stuff over the last number of years in Germany and the UK. If I had to ask you a question, of all the talks that you've given, where's the most interesting place you've gotten to visit to deliver a talk?
The most interesting place to deliver a talk, honestly, was in the UK with the chapter that was in Edinburgh.
Oh, lovely. Edinburgh is a lovely city.
Yeah, and it was really great because basically I did a round tour. So first day London, second day Edinburgh, and then going back to Germany. So
Wonderful.
if I get the chance, I would like to do it again.
Well, as a Google developer expert, we really value your time and effort that you put into delivering these talks and visiting us all around Europe. So there's one last question before I let you loose. This is a question I love to ask. You've interacted with some Googlers before, right? You know the guys. So
Yeah.
when they have a meetup, they meet people for the first time. They say, "What's your googly fact about yourself?" So a lot of people know my googly fact is I got married on a TV show. So that's a pretty interesting one. What would your googly fact about yourself be?
My googly fact about me is basically I got into the company where I now work only because I met Goose, who's another GDG organizer from Hamburg, and we met each other in San Francisco. And then I tweeted that I need a new job, and basically he brought in my new company in my Twitter timeline, and they hijacked it, and then I started working for my company because of GDG and meeting the people.
Come on, who's your company? Put it up there. Let's get a bit of advertising going.
Yeah, so my company is Kubernetic. We are creating an open source software, which is also called Kubernetic, and it's a multi-cluster automation for multiple Kubernetes clusters. So you manage all of your Kubernetes clusters in all of the different clouds and on-prem over one interface, and also like your edge data center. So we have like an installation where it runs directly next to the production line of companies, and also in the cloud as well. So worldwide Kubernetes management from one single console.
Sounds fantastic, Mario. Well, I hope you do very well. I know you'll do very well, but I hope we can help in some small way. Nice plug there. Okay, Mario, I will throw myself off your stream. I will be in the chat if you need anything, but off with you, I suppose. Good luck.
Yeah, thank you very much. So hello everyone. We are talking today about the going away of the pod security policies, which probably all of you folks that worked with Kubernetes so far have maybe heard of it. And what do we do now since this is going away? A quick thing about me. So I'm, as discussed, I'm Mario. You can find me under @mfahrland in Twitter. I do, as I mentioned, stuff for Kubernetes, and I organize the GDG Cloud in Munich. So if you ever come by Munich, just pay us a visit. And I'm also a GDE for Google Cloud. So policies. Why do we have them? Why do we need them? So Kubernetes is a complex system, and we have like this declarative style that we have in Kubernetes to define what's going on in our clusters and what we do in our clusters, and we need policies to make rules on our cluster and to enforce security. Like you heard in the talk before, security should always be part as soon as you start. And we also want to have like specific definitions in our clusters, because maybe not all of the users that consume our cluster are in the end able to get on this security level or have the knowledge to get on the security level that you should have as a operator of the cluster. So policies help us to enforce specific resources in our clusters and how they can behave. And we always need to have a look from a perspective that comes who is doing what in your cluster. And the further you are away from the operations part, the harder it gets to see the bigger picture. And so for this, we need some kind of security system, and there our policies come in place. We have external tools like Helm, but with Helm we cannot ensure like specific rules that are needed in a specific environment. So we have the luck that we have admission controllers, and with the help of those admission controllers, we can mutate and generate everything that comes into our cluster. So when we have a look back and see the whole structure, how we do our, or how we should do our infrastructure, we also want to have policy as code, because everything that we have as code, infrastructure as code, it's always a big topic. It's easy to reproduce, it's easy to control, and it's easy for everyone to get into it. So there should always be like this 3-step approach that we have. Like we have in our CI/CD pipeline for our infrastructure, we should check our manifests. Then we should have in our admission controllers the option to either block incoming requests or mutate incoming requests or even generate incoming requests. And when it then runs and when it is gone through the pipeline and it is in our cluster, we should have it in our cluster runtime, that we have like scans and reports so that we can see what is happening in our cluster. Is this okay? And do we need to improve it in any kind of way? So I copied directly from the Kubernetes documentation. So we have different points where we can add those webhooks. So we have our API request that comes in. It goes into our HTTP handler. We need to authenticate in our Kubernetes cluster with RBAC or with the kubectl config that we got there. And then we have the first option where we can put in webhooks that basically can mutate everything that comes in there. Then we have our schema validation, and then we have also our validation admission, where we also can now put in a webhook that changes all of the incoming requests, and then everything goes persistent into our etcd. So, but why do I need now pod security policies, or why did I use pod security policies in the past? So pod security policies are or have been a feature since the beta version of 1.13. So it's basically from an idea like role-based access control for pods. So we have in our pods that run in our cluster, we can basically restrict various options how those pods are running. So we can restrict the usage of privileged containers, so that pods can run, that the containers that run inside of the pods can be run in privileged mode. We can restrict the usage of the host name and the volume types and the file system and some root privileges that we can reduce. So we have basically we have 16 rules that we can restrict or could restrict with those pod security policies. This was always a good start to basically secure your cluster so that everything is like in a little bit more secure way. Of course, it's more annoying for people because the people then need to, they need to follow the rules, and not everything can run out of the box. Okay, how did it look like? So basically, we applied it. We applied to the cluster a policy, and we added a spec, and we gave it a name, and then we could use it. The problem is that if you create this, it does nothing. It doesn't affect your cluster at all. So basically, you needed a service account that needs then to be authorized to the pod to enforce this policy. So this brings us to one issue. If I create new policies, and if I then create them afterwards and I enforce them, everything broke, because this was applied to everything. So nobody, it was just blocking. It could destroy basically everything that run in your cluster. Also, you have the problem that when everything was created, that it sometimes the authorization then failed and you couldn't do anything. So what else was the bad thing? So the first thing was it got huge usability issues. So you couldn't do anything out of the box. It was hard to put in. You needed to do what you needed to know what you want, and there was no preview mode. So you couldn't just spin up a policy and then let's see. And in a test mode, it was either you applied it or it didn't work. Also, this is quoted by the original maintainers of the pod security policies. There was the problem that they were so confusing and also a little bit cumbersome, because you needed to name them in a proper way, because based on the naming, they building on each other. So basically, you started with 1 minus fully open, 4 minus less restrictive, 9 minus most restrictive, so that you have like this order. So you couldn't define in which order they were applied. Also, there was not the possibility to create your own policies. So you were basically stuck with the 16 predefined rules, and that's it. So if you wanted, for example, like we heard it in the talk before, if you wanted to restrict your pods pulling from a certain registry, you couldn't do this because there was no pod security policy in it. And they came to, after a long discussion, they came to the point where they say, we don't use it anymore. So pod security policies are deprecated since 1.21, and they will be removed out of Kubernetes with version 1.25. But what we do now? There's a easy, they said, okay, we cannot completely remove them, so we need to bring in some kind of alternative, or at least less thing that you can use. So we brought in pod security admissions. Pod security admissions are in alpha state in Kubernetes 1.22, and they use pod security standards. So these basically are on a namespace level, and they apply those restrictions to your cluster on a namespace level. We have 3 restriction levels. So we have now enforce, which will basically, if you have this restriction level, it will straight out reject the pod if it doesn't follow the rules. You have an audit mode, which will track violations inside an audit log, or a warn mode, which will basically trigger a warning to the user. And there are 3 standards, and you cannot extend them and you cannot change them. So we have like privileged, which is unrestricted policy. Basically, everything like before. You can do everything that you want. We have baseline, which basically removes some of the abilities of the pod, but is still fairly open. And we have restricted, which basically is based on the hardening guide for pods, what pods should do. But this might be too restricted for things like databases or applications that you're running in there. This is not so much, right? This is less than before. I mean, we went from 16 to 3, and it's even less. So what do we do now? The good thing is, or the official recommendation is, use an external policy provider. And the good thing is that we are in this great open source world, and there are some really, really cool projects out there. And I want to mention now three projects that you can use in your cluster to have an alternative, or not an alternative, but something to use once PSPs are gone. And for the beginning, we will look at those two, and I have one more bonus for you. So we start with Open Policy Agent and their Gatekeeper project. That is the implementation that is running in Kubernetes. And then we will have a quick look at Kyverno. All right, so I jumped over one. So we have the Open Policy or OPA Gatekeeper. It is in the project state of for the Cloud Native Foundation of Graduated, for OPA, not for Gatekeeper, but Gatekeeper is part of OPA, so it's also in Graduated state. It's a sub-project for Open Policy Agent, which is great because if you're in the luxury of already having OPA in your company, you can then just use it also for your Kubernetes clusters. So basically, you can just combine everything and use and then have one policy management throughout your company. It has its own declarative language, which is called Rego, which makes it a little bit more complicated because you basically then need to learn a new language. The good thing is it uses libraries, so there are a lot of libraries that you can utilize to that predefine most of the use cases. How does this look now in the end? So we define here now a new rule, as we saw before. This is the rule that we will create for using Open Policy Agent for restricting running as containers as root, and this is then what you need to write. It's a little bit more code, and I even couldn't put it all on the slide. So yeah, it's everything that you define there. The good thing is with this Rego language, you can basically define anything you can think of. So any rule that might come in mind, or any restriction that you want to enforce on those pods in namespaces, in environments, you can basically create those rules because Rego is so powerful to create all of these options. And once you have this, you then basically add this constraint to a pod, a namespace. So you then can basically everything assign everything everywhere. And as you already can see now, you have the option to basically say enforce a try run. So basically you can test what policies you do and you don't crash your cluster completely. The next project is Kyverno. Kyverno got last year in the Cloud Native Foundation status of sandbox. And in the contrary to Open Policy Agent, which was there before, and they only put the Gatekeeper project on top of it, it was especially designed for Kubernetes. So the good thing is it was created with the mindset of we want to use the same style like you do in everything in Kubernetes, which is the declarative style. So if you can manage Kubernetes clusters and you used to use YAML files and config files, you're then able to easy to adapt the writing style because you use the same declarative way. And this makes it very, very easy for for users that use Kubernetes before. And Kyverno also comes from the same idea. So it's a Greek name for govern, as Kubernetes means helmsman. How does this look like? So we have, as we saw already, we have our API request that goes to the HTTP handler, and in the mutating admission and in the validating admission, we have the webhooks, and those webhooks then basically can say, okay, everything that comes in can now be either checked, mutated, or updated. So you have there the option to say, okay, what do I put in, what I want to enforce, and I can even then change existing incoming configurations so that it's not also pushing and, oh, this is an error, but it's basically it could also fix things there. So, and we have the difference there is we have like a set of rules, but I never found any restriction that I wanted to create where I couldn't use any of the defined rule sets. There is a discussion in the GitHub project of Kyverno going on if they should also create like a self-defining rule language, but so far it wasn't taken care of because there came no rules that couldn't be managed with those predefined rules. And how does this look like? So we define here the same thing again, privileged containers, disable privileged containers, and as you can see, it's like it should match pods. It should not go in the it should not use the should not use the privileged mode, and you have like this easy written down declarative style that you used of Kubernetes. Who wins? It's not so much of a question of who wins, but a comparison of what's the pros and what's the cons. So for Gatekeeper, you can basically, if you already have OPA in your company, you can reuse your policies, and you'll probably have people that already can write Lingo. It also got a big community, so basically every use case that you probably run into, it already got covered at some point. It has a big community. And the problem that we have with OPA is you need to learn Rego. And the mutation state is not so great, so changing existing incoming requests is kind of hard. And it's not easy to read, as we saw in the example inside of the slides. For Kyverno, it's Kubernetes native, so we have our declarative style. It has solid mutations, which is quite fine. It's easy to adapt and easy to use. And on the other side, it's, as we discussed, it's a little bit younger. It lacks like the programming language for really, really complex policies. But as I mentioned, for my case, I never run into any use case. So in the end, too long, didn't listen. If we have really highly complex policies, use Gatekeeper. If you only have like the basic default policies that you want to apply, use Kyverno. Also, there are a couple of other projects in there. For example, KubeWarden. It uses the WebAssembly And so basically bring your own language, and everything that compiles into WebAssembly you can use. You can basically then codify your policies, and there are also libraries for policies. But to be honest, I didn't had the chance yet to test it out in production. Everything where, if you want to just check it out, there you go. These are the separate points to the separate sources that you can have a look into. And thank you very much for listening, and maybe we have some questions or time, we will see. And yeah.
Hello, sir. That was a fantastic talk. Thank you very much, Mario. A very deep technical conversation, and it's really specialized. There's a lot moving, a lot going on in the Cloud Native Foundation right now, and a lot of new things getting added to beta. So, how do you keep up with it all?
It's hard. To be honest, the good thing is that we have our Slack work channel, and a lot of our developers that work on our open source software are also core maintainers for Kubernetes as well. So they always post the hot shit, I would say. So we see like the interesting papers, and yeah, I try to follow most of the CNCF talks and workshops that they post online.
That's even a full-time job in itself, keeping up with everything that's going on, especially in the Kubernetes world.
Yeah.
You know, ever since Istio started, everything just started getting piled on top. It's service discovery. There's just so much cool stuff that's happening.
This 3 months release cycle is so crazy that you have basically every 3 months you have a new Kubernetes version coming in. It's just fast.
Absolutely. Kubernetes being built on containers. Have you seen much of a drop off in the use in Docker since they've decided to charge for their services?
Yeah,
what containers are you using?
Basically, all of our customers are changing to Containerd, because I mean, there's not so much difference in it, and Containerd just uses less resources. So you're saving basically resources by not having Docker as a runtime. So especially big companies where every single CPU counts, and you have like this thousands of euros per month, they want to save as many resources as possible, and you see the switch is happening quite fast. So as soon as they hit like Kubernetes 1.20, usually they switch to also the container runtime. I mean, sometimes it's tricky because there are applications that just fail and they need to be updated, but the companies are willing to take those time to switch.
Well, I mean, that is the price of progress, and that is what a CI/CD pipeline is for, my friend.
Yeah. All right.
Well, that is it. Unless you have any final words for the people watching and the people that will watch this on the record.
Thanks for having me, and hopefully we see each other soon in in-person meetups and conferences in the following.
That would be fantastic. I'm delighted we're getting back to in person. I'm really looking forward to the next time you can come over, Mario. We'll do some really interesting talks, maybe a live demo. See if the demo gods will be with you.
Usually they are.
Pre-record all the way, my friend.
No, never pre-record. No, I never pre-record. If I do a live demo, I go through all of the pain.
Oh man, superhero. Okay, thank you very much, Mario. We will talk to you again soon.
Bye. Have a great one. Bye.
Bye. So that's it. We have a tea break now for the next 30 minutes. We'll be back here at 4 o'clock. We look forward to seeing you with our next speaker, Martin Omander. The cloud is complicated. Here's how you can simplify it. I'll see you guys in half an hour. Hello, everyone. We're just going to join back on the stream. I know it's a little bit early. Hello, Martin. So
Hey,
great to see
David.
you all the way from California. How are
Yeah.
you, sir? Yes, we were just having a chat offline there. Yes, we do have an in-person part to this to the conference where we are live in London. We have about 180 attendees here. I'm presenting live from the venue, so I have the madness going on around me. It's great to be back in person. I'm sure you can hear all the guys. They're getting excited. It's great.
Yeah, I wish I could be there in person. It would, but I don't. I almost don't know how to handle myself at a live event anymore. It's been so long.
I know it. 2 years. It's been a long 2 years, and a lot has evolved in tech as well since we haven't been able to show each other things or show each other new tricks and tips, and being able to spread the googly love between each other. It's a big change.
Yeah. Right. Yeah.
So how are things in Mountain View over in California?
Well, it is overcast. It's going to be bright later today, but to be honest, I just got out of bed. As you can tell from my hair, probably. So I don't know quite
it's
yet.
better than my hair now, Martin. Come on.
Oh.
So we're just 1 minute too. So I just want to give people a chance to jump in. We have a comment or two. Are people starting? Oh, we have Sean O'Gorman. Tricks and tips for the win. You're dead right, Sean. We have a few people online eager to hear what you have to say, Martin. So I suppose we'll do the formal way we're doing things. Thank you for joining us, Martin. For anybody that doesn't know, Martin is a cloud developer advocate at Google. He's been there for nearly 16 years now at this point. So he's obviously doing something right, or they are to keep him, one or the other. He's been to many DevFests. He's been to some very interesting Google conferences. So this leads us into, I suppose, the icebreaker questions, Martin. What's the most interesting place you've gone to do a talk with Google or with anybody?
I think it might be Minsk, Belarus. It was really different in some ways. It was bitterly cold, but so similar in some ways. Like people I met on the street in Minsk, different culture and everything. But then you get into DevFest, and developers are the same everywhere, whatever country they're from. And happy to learn new things and just like to talk about tech. And that was a big contrast. It was so much fun.
And was that through the developer expert program you went through there, or as your DevRel lead?
Yeah, it was GDG Minsk that I was speaking at a big old factory that had been closed down many years ago and was now sort of startup space.
Wonderful. That sounds amazing. I love the startup culture. It's just so full of energy. And if anybody watching is interested in the Google Developers Group, we're always looking for extra volunteers, helpers, and leads. And the Google Developer Experts program is also looking for people if you work with Google Technologies and you fancy being able to teach other people. Look it up on the internet, GDEs, Google Developer Experts. They're always looking for excellent people who love to share. The last question I want to ask you, Martin, is what is the googly fact about yourself? Most people know mine is that I got married on a television program. So what would your googly fact be about yourself?
Once I ended up on a plane with Larry Page, one of the Google co-founders, and he asked me. This was his private plane.
Did you get to say hello to him? Oh,
yeah, he was sitting right opposite me, and then he said, "Oh, have you flown with us before?" I said, "No." And then he said, "Oh, okay, let me just tell you about the exits and where the life was lit." So I got a safety briefing from at the time from the Google CEO.
But did he stand up and do the whole but thing and put the seatbelt?
He did it. He was sitting down. He was very relaxed. He just said, "Oh, back there is the bathroom. Over there is the exit, and here's how you fold your seat." And
that's wonderful. Okay, well, look, I'll give the people what they've come here to hear. Would you like to share your screen? I can just add it to the presentation stream.
Let's do it.
Okay, remove this one, add your one, and I will back out of here. Thank you very much for joining us, and we look forward to hearing you talk.
All right, thank you, David, and thank you everyone for attending, and thank you for staying till towards the end of the conference, so that gives me a chance to wake up here in California and join you. I'm so happy to hear that some of you are attending in person, and all of you attending streaming as well. Good to see you all. Thanks for being here. So today, I'd like to share something that I'm personally excited about and that I also work with, which is cloud computing and how the cloud is complex, but we can simplify it. So first, a little bit about me. You heard some from David. I was actually born and raised in Sweden, and then I lived in Silicon Valley for these last 22 years. I'm calling in from Mountain View, California now. And I worked at 3 startups as a software engineer, done a bit of consulting before that, and then worked at Google for 15, yeah, it's almost 16 years now. And I'm a cloud developer advocate. My previous job at Google was to support Google developer groups in North America, US and Canada. So much fun. So as David was saying, if you don't know about Google developer groups, you're attending a Google developer group event right now. Go and check out if there is a Google developer group in your local area, or one that has online events that you'd like to attend. The Google developer groups are a great way where practitioners, developers, people like you and me, people who have sort of like to get our hands dirty with technology, we get together and share tips and tricks, and it's an amazing community. All right, so cloud computing. I would say that there's never been a better time to be a cloud developer. I would also say that there's never been a worse time to be a cloud developer. What I mean by that is, if we look back in history, I'm a big history buff. I love history. So bear with me. I'm going to take you on a short historical detour here. Back when dinosaurs roamed the earth, computing was done on mainframes. Everybody was on the same computer. All programs were running on the same computer, and they could sort of trip each other up, these various programs, mess each other up. But everything was simple. Everything was in one place. Then in the 80s, late 80s, we started with client server, because now all of a sudden we had these machines, these powerful computers, not just terminal, but computers sitting on workers' desks. So they could have their own computing power on their desk, but then share some stuff on the server, like some server-side logic or server-side data. So we separated the clients a little more, the processes a little more. Still, one could, one client might run a query on the server that took down all the other clients. After that, we figured out, let's split up the server as well. So we started doing virtual machines. We started seeing this come around in a big way, maybe 10, 15 years ago. Let's split up the server in multiple virtual machines too. So if one is taken down, we can easily spin up another one. One client can take down the whole server, for example. So we got a little bit better insulation between clients. And now, of course, we said, okay, virtual machines are kind of heavy to start. They take a long time to start, require a lot of processing power. We can only run a few virtual machines on a real computer. So let's do containers instead, which are kind of lightweight virtual machines. You can spin up a container very quickly, and you can run many, many containers on one virtual machine. So this is a story of more effective process isolation, from mainframes where any program could trip any other program, to containers where we have things nicely packaged up on the server side. Now, how do we manage these containers? Well, it's simple. We go to the Cloud Native Foundation, and we look at their container landscape, and it looks like this. So we just go in here and we pick half a dozen products that we need for container orchestration, container deployment, container testing. There is so much to choose from here. And all these different companies and have these software packages and hosted services for containers and what have you. This is where the worst part of being a cloud developer comes in. Navigating this landscape is hard, and knowing what to use, because containers was relatively young still, right? So we're still sort of together figuring this out. How do we run code and how do we manage data on the server? It is too complicated. It's never been a better time to be a developer because there's so much choice. There's never been a worse time to be a developer because there's so much choice. So instead, there is one way possibly around this. Instead of saying, let me assemble my own stack and try to pick 10 boxes in this diagram and put together my own server-side stack, maybe I can do serverless computing. With serverless computing, you still run stuff on somebody's server, Google server or Amazon server, but to you as a developer, the server doesn't really look like a server. You just upload your code and your cloud provider takes care of everything. So you don't have to go in here and pick out your stack of 10 different products and make sure they talk to each other. Your cloud platform provider has done that already. So there are two ways basically here of doing server-side development, modern server-side development today. You can do containers. This is sort of Docker, Kubernetes. It's over here on the left. Or you can do serverless. This is also called functions as a service. You see it there, FaaS. Or platform as a service, PaaS. So these are the two different mainstream modern ways of doing server-side development today. I mean, you could also do things like, have a physical server and upload your code to it. That is kind of a caveman way of doing it, and we try to avoid doing that today. If you're doing that, talk to your team, talk to your manager about maybe going one of these two routes with containers or serverless. Anyway, why would we want to go containers? Well, it gives us fine-grained control. We can use any language. We can move these containers around between the cloud providers. We have great control. You saw in that big graph before with the hundreds of boxes. You can pick whatever stack you want. Of course, the disadvantage is you have a lot of maintenance work. You have to pick all these products. You have to provision your resources ahead of time. You have to say, for example, I think I'll have a lot of traffic, so I should probably buy or rent 3 web servers. Maybe. Did I pick too many? If so, I pay too much. Did I pick not enough? If so, it won't work. And I am paying for idle resources, right? If I rent 3 virtual machines to run my Docker containers on, and they're not all used, and some money is lost and wasted. On the other hand, on serverless, I don't deal with infrastructure. It's great. And my cloud provider manages security, which is great. And I only pay for what I use. So on Saturday, when I don't have a lot of traffic, I don't pay a lot. And on Monday morning, when a lot of people come in and use my app, I pay more. But I pay only for what I use. Of course, then my app isn't portable, right? I can't use any language. Like Google Cloud Functions, their support for half a dozen languages. AWS Lambda is another one. Their support for only some languages, not all. And you can't easily move. So for example, AWS Lambda function and Google Cloud Functions, it's not easy to move code between them. Also, you can't just include any old library you want. There is a sort of list of libraries that work with these services. So we have a problem here, right? We can go with containers or serverless. Advantages, disadvantages. I mean, we can navigate these here, but far better. And what we're seeing to start happening, actually, we've seen it happen for maybe 3 or 4 years now in cloud, is that containers and serverless are merging. And we're seeing all cloud providers do it. Google, I believe, was actually the first one to merge these, and we're seeing the others coming along as well. The Google product that does this is called Cloud Run. So Cloud Run tries to bring together the advantages of serverless and containers while skipping and sidestepping the disadvantages. So we get all the good stuff on the left, all the good stuff on the right. And I'll show you a little bit about what a Cloud Run application might look like. So here's a piece of an application that I wrote for a veterinary, imaginary veterinary clinic. It's a simple REST API where a client can call the pets/123 endpoint on the server, HTTP, domain/pets/123, where 123 is the ID of the pet to get that medical record for that pet. So this is what it might look like. This is a Node.js application. If you've done Node, you might recognize Node, and it's using the Express framework. So here on app.get, you see there it listens to get requests, and then it just does a lookup in Firestore. That is a serverless database that Google also provides. Or you can have SQL database you look things up in. So very simple code here. Python, if you wrote this in Python, it would look very similar. If you wrote this in Java, it would be a little more, it would probably be a Spring Boot application, but it would look similar. So once you have your business logic, like this index.js, or the equivalent in Python, or Go, or Java, or Ruby, whatever language you want, or .NET. Once you have that, we need to deploy it to the server. And with Cloud Run, we have, of course, we run the command there at the bottom, gcloud run deploy. That's all you run at your command line, and you will be asked, what region do you want to run this in? What kind of security do you want on top of it? It will look for package.json, and this is all your Node heads out there. You know that this is where your dependencies are, what libraries are using. The equivalent for if you were to deploy a Python function would be requirements.txt, or in Java land, this might be your POM file. This is your dependencies so that Google knows what libraries does your code depend on. You would need that. Also, optionally, you would provide a Docker file. Now, if you know what a Docker file is, great. You can write up your Docker files and include them in your Cloud Run deployments. If you don't know what a Docker file is, don't worry. Just don't include it. Google will figure it out. Or Google will actually use Cloud Native build packs, which is also an open standard from the Cloud Native Foundation. And these build packs will basically write your Docker file for you and wrap everything up and make sure that best practices are followed. But if you really want to tune and tweak your Docker file because you have experience in that, just include the file and it will be considered. It will be included in the deployment. So what actually happens here when we take this business logic here and we take these files here and we run gcloud run deploy? Well, gcloud takes all your source code and zips it up and sends it to the server where it's all installed and it's all packaged up in a container. So if you've heard of containers before, you know what this is. If you haven't really heard of containers, or like me, not too long ago, I'd heard lots of about containers, but everybody was talking about containers like if they knew what they were talking about. And at some point, I was almost too afraid to ask what it was. But it's very simple, actually. In days of yore, back when I worked at a startup, I would write, the equivalent of index.js here. This would be my business logic. I wrote this, my code, right? Then I would deploy that to the server, that file only. And it would break because the server missed some library that I had on my local workstation, or the server had the wrong version of some library. So that was the problem with doing things in the pre-container days, back when I worked at startups. What we've figured out as a community since then is that your application is not just your business logic. It's not just the yellow box. It is also those gray boxes there, all your libraries that you depend on. And your code depends on perhaps very specific versions of those libraries. So nowadays, instead of just deploying index.js, like I did a long time ago, we now deploy a whole container where we say index.js and the Express web server, this particular version number, and the Firestore client library of this particular version number, and so on. So we deploy the full container. That means that it's safe to deploy. And we won't get that thing which, it worked great on the developer's machine and it crashes and burns in production. So containers are great. Now, let's say we deploy this to Cloud Run, and let's take it for a spin. Let's see what kind of load we can put on this thing. So actually, I did a load test with this code that you just saw. Very simple, as you saw, it was a very simple REST API. Just does a database lookup, returns the pet record for the pet of that ID. I did a 1-minute ramp up. Then for 3 minutes, I ran with 300 requests per second against this REST API. Then a 1-minute ramp down. Every request generated 1 database read, as you saw. So what kind of, how did the test go? Well, we see here that serving instances was 85. So Google actually spun up 85 servers for me to handle this load. At the end of the test, Google spun 80 of them, closed 80 of them down, and kept 5 on hand just in case traffic would spin up again. So I didn't need to set this up or tell Google to run more machines. Google created 85 machines for me, or rather installed my container on 85 machines to be able to handle this load, and then spun them down. This test generated a middle box there, 137,000 requests. There were 0 errors. Great, 0 errors is always good. And latency, the box there on the right, we got a median latency was 49 milliseconds. And the P99 was 120 milliseconds. P99, by the way, this is very cool. I like saying P99. You should do 2 in meetings to impress your coworkers. And you will know that P99, they might not know, but you will know that P99 means 99% of requests came in under 120 milliseconds here. By the way, as an aside, P99 or P99.9 or P95, P90, you decide. Measuring that value tends to be more valuable than measuring average response time or median response time, because they're always outliers. So anyway, that's a bonus tip of the day. Measure your P99 and see what it is. Anyway, we got some great data here from this REST API. I used literally only the code you saw here a few slides back. And actually, a couple of metrics that are not in here, or that might appear shortly, that I think are even more important than the ones we see here, are these. What did it cost to run this test? We had 85 servers running for ourselves. We had actually a sort of mini data center of 85 computers running for us for a few minutes. That cost 8 cents. Well, actually, this would have come in under the free quota, but assuming we had gone over the free quota with the rest of our company's workload, then this would have cost 8 cents. Installing and setting up and figuring out how to connect 85 virtual machines would cost more than 8 cents in engineering time. Also, speaking of engineering hours, scaling up to handle this load took 0 engineering hours. I just ran the code you just saw. And that is, I think, where the great saving is in running serverless containers. You're running containers, so you have good isolation, safe deployments, and you're running serverless, so you don't have to spend a lot of engineering hours futzing around with servers and configuring them and figuring out the security and figuring out how to scale up and scale down. Google does all that for you. Cloud Run does all that for you. So with that, remember, we come from mainframes, client server, virtual machines, containers, And I think that we're seeing now the last few years, where more and more people are running on serverless containers. You should too. Simplify your life, run it on Cloud Run. And there's my Twitter handle and email address if you have any more questions after this. And now I believe we'll have some more questions during this. If you have any questions right now and don't want to email me later. Is that right, David? Do we have some questions?
I can ask you questions, or I can check what's going on here in the chat.
Yeah.
We have Sean O'Gorman saying, "Go on, the lads, tricks and tips for the win." So I think they're looking for tricks and tips on Cloud Run. What would your top 10 top 10 is a bit much, I think. What's your top tip or top 2 tips for using Cloud Run as someone who may be new to the system?
Yeah. If you're new to containers, don't worry about Docker files and figuring out Docker. I mean, Docker is not super complex, but just ignore it. And just if you deploy without having a Docker file, then Google figures it out. Google pulls in a build pack. Actually, build packs are kind of nice because also you know then that you have the latest version of everything and the best security practices are followed with build packs. So yeah, if you're new to this, don't worry about Docker at all. People will tell you that you need to learn Docker. You don't. It used to be that you had to learn Docker to do containers, not anymore. I think another tip would be let's see, right. Another tip I think is if you go serverless with Cloud Run, you probably want the rest of your stack to be as serverless as possible. That way they sort of fit well together, and you don't have one part of your system where you don't need to worry about operations and another part where you do need to worry about operations. That's not a good operator experience for you or your company. So go with a serverless database if you can. Firestore is a great serverless database. That way, everything is serverless. There is very little operations work to be done, either on the compute side, Cloud Run, or on the server side, where you have Firestore.
So we have Gareth Howells. Good morning, Martin. How do you get ready for doing talks this early in the morning? It's very early in the morning for you. So did you have everything prepared last night? Is this a talk you give on the regular? How do you approach giving talks?
Yeah, how do I prepare? I clearly did not have time to fix my hair, as you can see. I had a cup of tea, and this particular talk, I've given a very similar talk, so I tweaked it. I always learn from every talk, especially from the questions. So I had last night and this morning I looked through it, and I'd previously added things I learned from audience questions last time. And then actually later today, after this, I have 2 reasons to be up early today. One, of course, is to give this talk to talk with you guys. And I really wish I could be there in person. It would have been so much fun. The other reason is that after this, I'm going to do some pair programming with my son, who is based in Europe right now for school reasons. So I have to get up early before he goes to bed.
Pair programming with your son. That's like the dream for a lot of people, isn't it? Following your father's footsteps.
Yes.
So Daniel has asked, what do you use to measure performance? A/B, work, etc.?
Yep, performance, server-side performance. I like that P99 value. Or that is the metric I like. Then the question is, what tool do I use? And of course, there are lots of performance measurement tools. I actually don't know them that well. The P99 value you can get from the console in Google Cloud Platform for Cloud Run. It has graphs on P99. So that's where I got it from. Then, of course, there are specific tools but I don't know much about those. But P99, just get it from the console.
Wonderful. So we have Sean O'Gorman, insights into benchmarks repos, who also adds, also tutorials or other case studies. Is there anything you'd recommend? We can send them out in the comments here. And they'll be on the YouTube forever and a day, because YouTube will be here forever.
Yeah. Yeah, we hope. Yes, it will. I think if you search for Cloud Run Quick Starts, that was how I got started on Cloud Run a couple of years ago. Because on Cloud Run Quick Starts, what I really like about those is that there are tabs there. You can pick your language, and then pick your favorite language, and then it walks you through exactly how to put Hello World up there. And once, we are all programmers, we know that once you've done Hello World and deployed it and it's running in the cloud, so anybody can reach it, that is 80% of the work right there. Then you can start, replace Hello World with your own logic, your own code. So Cloud Run Quick Starts are actually really good. I mean, I'm impressed with my coworkers who wrote those.
That's a big shout out to Rich Rose from London, who is a big proponent for Cloud Run and does a lot of the security talks and the teaching side. So that's a big shout out to Rich Rose. Sean, if you're looking for more talks, look up Rich Rose on YouTube. Coda Rosie, he's a great resource. And also come to your local GDG. We'll if it's important to you, we'll run a code lab. We'll help you guys get started. We'll bring some experts. We'll get this rocking and rolling. We'll do this in person. We love it.
Great.
So I think we're all out of questions, but I think we've taken up enough of your morning. We'll let you get to your pair programming with your son. I'm jealous when I mention coding to one of my sons. They go, gone.
Oh, right. That is how my other kid responds. Yes.
Well, this has taken us to the end of our DevFest journey for today on cloud, DevOps, and SRE. Martin, it's been wonderful speaking to you. A very interesting topic. I'm sure everyone is going. You'll have an influx of new Cloud Run users over the coming weeks, hopefully. And thank you very much for giving us your time.
Yeah, thank you, David. Shoot me an email or hit me up on Twitter if you have questions. Thank you very much for staying till the end, and have a good Saturday night.
Happy DevFest. See you, Martin. Thank you very much for joining us on the Cloud, DevOps, and SRE channel. This concludes our presentations for the day. These talks will be available on YouTube, and we look forward to seeing you at the next live event. Goodbye.